you'll be learning again. We never stop learning. That's why we love
I
this.
remember how relieved I was when I was through the last time, and it's all rushing back now already. So
yeah, yeah, that's what happens when we chant 4 more years and yep, Carol got you, but I'm sure we're gonna be just fine under your leadership, and I'm sure we'll all pitch in to help. I mean, it's that I could see from my first Alcon, it's definitely not a solo effort. Everyone pitches in from each of the regions.
Very much the case. Yes.
Yep. Excellent. All right, Scott. I have 703.
We are live already.
Okay. Well, you know what, David Eicher,
I'm just saying hello.
Yeah.
Listeners already logged in.
Yeah. There's a fairly new discovered planetary in Aquila, and I know a couple people have imaged it. One of them is a gentleman who sent the image to me from Michigan. Be on the lookout for an article that may include that image with credits to the imager.
Excellent. Sounds good.
Yeah, I want to do, my article would feature the Milky Way and targets for each type of observing along the plane. And I want to do some of your obscure ones. I don't, M16, M17, M20 and 22. We image M8, we do those all the time. What about these small planetaries? What about NGC objects within the small Sagittarius cloud? So I'm hoping to point things like that out for the big scopes, and for binoculars, I'm hoping to point out some things bright and some things not so bright along the plane of the galaxy, and then do it in sections. So Cygnus, Perseus, Perseus, and the Orion Spur, and of course the galactic core. And then if I ever get to the south, I can do the other regions and continue the series. So that is the plan.
We'll see immediately after the universe was born, it was too tiny and too hot for protons, electrons, and even photons to exist. Within a second, it had expanded and cooled enough for protons and neutrons, collectively called baryons, to form. Almost instantly, there was a rapid burst of sound waves triggered by tiny variations in this particle soup. Scientists call these waves baryon acoustic oscillations. The pressure waves traveled outward for 400,000 years until the universe thinned and cooled enough for light to travel through it. The universe became transparent, and the waves froze in place. Over time, the denser regions formed by the waves encouraged more star and galaxy formation than other areas. The imprint of those waves expanded with the universe, slowly accelerating due to dark energy. Today, with our snapshot of the universe, there is a slight tendency for galaxies to be separated from each other by a distance related to that expanding ring radius. Although difficult to see, it is detectable as a slight bump through careful surveys of many galaxies.
Well, hello, everyone. This is Scott Roberts and David Levy, and we're here at the 155th Global Star Party. And the topic, or the theme, is shifting cosmic paradigms. For me, I think that I personally have had those experiences where, it felt like maybe a plastic hammer hit me on the back of the head when I realized certain things about the universe that I was exploring. And it is that an awakening to me, and when I am working with the uninitiated, the the newbies that might be out there looking through my telescope, I can tell when they have a similar experience, and they realize that their world, and I've talked about this many times, that their world just isn't about going to work and paying their taxes and doing stuff at home and waiting for the next movie or whatever. Okay, that they are on a planet. We're going through space at incredible speeds, and we're connected to everything out there. So that's those are some of the moments for me where I organically experience that kind of cosmic paradigm shift. David, what do you think about all that? You have discovered things. You have been at the forefront of planetary science, and so you've been closer to the fire than I have, for sure.
I might have been closer to the fire, but I regret that I'm not on fire right now, or more or less. I am going to give you my contribution to cosmic paradigms today, but it's not in the form of a globular star cluster or a galaxy or a comet, much as I'd like it to be, but it is in the form of a poet. One of my favorite poets, and if you don't mind, I'd like to tell you a bit about him. His name was Alfred Lord Tennyson, and boy, I loved his stuff. And he was born in 1809, and he lived to a ripe old age until 1892. He was a very successful poet, but he had a rough start. Poems, chiefly lyrical, got terrible, terrible reviews. The review in Astronomy magazine, David, why did you give him such a bad review in Astronomy magazine in one of your 1834 issues?
We were tough, 175 years ago. That's all I can say.
Yeah, I guess you were wrong. But anyway, he got a lot of bad reviews, and it hurt the man. He was very upset. He had good friends. His best friend was Arthur Hallam. And then one day, he's kind of sitting at home, and he's bemoaning the failure of his poetry career, when his sister walked in and said, "Alfred, sit." And Alfred sits, and she says, "I've got the worst possible news, and I don't want to tell you, but your friend Arthur Hallam had a stroke yesterday and died instantly. And he was like 24 years old. And Alfred was devastated. So actually, first of all, the failure of his poems, and then the death of his best friend, he was absolutely devastated. And I can relate to that right now, as some of you might understand. But he kind of, after he sort of accepted the fact, he started writing some quatrains, little four-line stanzas devoted to his friend. And he'd write one, and he'd put it in a little box, and he'd write another and stuff like that. And then he decided he was going to get back into poetry again. And in the early 1840s, he wrote a bunch of poems that he labeled The Princess. And God, they were beautiful. In fact, these poems are remembered today as being among the finest lyrical poems ever written. And Chuck Allen here, I think, could write poems as good as that. And David, if he put his mind to it, might be able to. But these were brilliant, including one about the Pleiades, where he says, "Here the Pleiades, hiding in the mellow shade, glittering like a swarm of fireflies tangled in a silver braid." And that was Clyde Tombaugh's favorite poetical quotation. He always quoted it to me. And he kept on doing those little four-line things. He kept on putting them in his box. And then one day, he opened the box, and there were like hundreds of them. And he said, I've got to do something with this. And as the 1840s came to a close, he was working on organizing them. He wrote the poem Ulysses, and Ulysses is the poem where he really introduced his readers, who by this time loved him, to his crashing closes. And he had this incredible close to Ulysses, where he says, that which we are. And the final line, to hunt, to seek, to thrive, and not to yield. I mean, he knew how to write end a poem. And he was working on getting these hundreds of 4-line stanzas together into an elegy. He called the elegy In Memoriam AHH. I wish I had known Alfred Tennyson, even though if I did, I'd be as dead as he is right now. But I do know his great-great-grandson, Jonathan Tennyson, who is an astronomer. Of course, you have to be an astronomer if your great-great-grandfather was a poet, or if your great-great-grandfather was a poet, then you have to be an astronomer. And I asked him, does the fact that you have this famous relative affect your work? And he said, I try to keep as far away from Alfred's poems as I can, and just live my life as I want to be, which was appropriate. Then I was in London, and I stopped by his office at University College London. And the first thing I saw in his office were 2 stanzas from In Memoriam. And I walked in, I pointed at the stanzas, and before he even said hello, he said, sometimes you just got to say, what the hell? Anyway, these stanzas are absolutely priceless. They're from In Memoriam, and they talk about geology. They talk about the nature of the earth, and they talk about how David Eicher one day is going to become an expert in fossils. He is going to become an expert in sedimentary rocks, and he's going to do this. And he took his interest in geology and the evolution of the earth, and he worked it into 2 stanzas from the Memoriam. And that, after this long introduction, is what I wish to quote for you today. There rolls the deep where grew the tree. O earth, what changes hast thou seen? There where the long street roars hath been the stillness of the central sea. The hills are shadows, and they flow from form to form, and nothing stands. They melt like mists, the solid lands, like clouds. They shape themselves and go. Thank you for letting me do this. Scotty, back to you.
Thank you very much. Thank you. I think that I just want to say something. I think that we are so lucky to have David Levy come on every Global Star Party and read a favorite poem or a passage or to give his thoughts. It's just a wonderful way to set the entire tone for the night. So, David, thank you so much.
Well, thank you, Scotty. And I kind of like to think that today, I mean, I know he's not, but what I like to think was that sitting in a corner with his headphones and on his laptop was Alfred Tennyson, enjoying the 2 stanzas from his most famous poem. He went from being a failed poet to poet laureate in just one couple of years. And
really? Wow.
Yeah. I mean, after Wordsworth died, 1850, In Memoriam came out, he got married, and he became poet laureate. And you can't really beat that.
Wonderful. Well, we are going to be talking to one that's familiar to all of us, which is Chuck Allen. He is about to be the acting president of the world's largest federation of astronomy clubs, which is the Astronomical League. but he's done this before, and he's back. He's back for more. Is it a labor of love, Chuck, or is it?
No, absolutely. I believe me, having done it before, I wouldn't do it again if it weren't. It's working with great people all across the country, and I'm leaving, in fact, tomorrow to present some of our awards in Philadelphia and New Jersey. So it's a lot of fun.
That's great. That's great. Well, we are excited about the new Alcon that's coming up in Bryce Canyon. I was at the Bryce Canyon event, and everybody keeps talking about how dark it was, and the fantastic talks and all the rest of it. But there was just a feeling of being there, and it just felt good. That was the main thing about it. You can go to see different things and experience different things, but if it somehow isn't resonating well, it becomes more of becomes kind of wears on you a little bit. And I've been to events like that. You're almost like glad that you're glad that you were there, but you're glad it's over. That's not so with Bryce Canyon. And that's not so without the Astronomical League conventions. Every time one of them comes to a close, I feel a little sad and not quite ready to go home, So this is, the league puts on an event like no other. And I do believe that the Bryce Canyon event, was it 2005? Is that right? 2009?
2011.
11, sorry.
Yes.
Okay. So, but that particular event was just, it was wonderful because I was there amongst friends. The weather was incredible. The skies were amazing. There was a kind of music in all of it, and so it was really, really cool. And so I can't wait for the next one. But I'll let you get your talk underway, Chuck, and thanks for gracing us once again.
Well, thank you, Scott. Is my volume okay?
Perfect.
Okay. Good evening, everyone. Since the topic tonight is shifting cosmic paradigms, I thought I would show just how fast they shift. And to do that, I'm going to start a slideshow here. Talk about some of the James Webb Space Telescope's new mysteries. Just what we need, more mysteries in science. I think the first thing we should talk about is the fact that the battle for seeing further in the universe has always been a matter of instrument size and technology, and as we'll see in a few minutes, theory as well. Let's just start with how far we can see with the unaided eye. The furthest thing anyone has reported seeing with the unaided eye is NGC 5128 in Centaurus. Stephen James O'Meara stated that he had observed this high in the sky from a southern observing location, which means he was seeing with his unaided eye something 13 million light years away. If you expand that to perhaps 7 by 35 binoculars, you can see almost 70 million light years. NGC 3607 and Leo is the furthest thing I've detected from Scott Harrington's report of observing many objects with binoculars of this size to see what the limits were. If you get up to a 3 or 4 inch telescope, you've got a shot at observing a quasar, an active galactic nucleus in Virgo, at a light travel distance of 2.43 billion light years. That's half the age of the Earth. It's really quite easy to see. Just find this V pattern and look for a little star off to the side of it, and you will be seeing that distance. But you can do a lot better. You get up to about a 10 inch telescope and you can observe a 14.6. Actually, it gets as bright as 14.2, putting it well in range of 10 inch telescopes. A quasar in a field with 2/8 magnitude stars, making it very easy to find. You find the 2/8 magnitude stars, you find this triangle, and you just go bing, 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 a little arc, to a quasar whose light has taken 9.6 billion years to reach your eye. That's twice the age of the Earth. This object's light travel distance is 2 trillion times the distance between the Earth and Neptune, to give you an idea of just how far you can see with an ordinary amateur instrument. With slightly larger amateur instruments, you can extend that to 12 billion light years of light travel time. And when you see this object, you will know that today, in whatever form it has today, it's actually out there nearly 24 billion light years away. Most amateur astronomy clubs have Dobsonians of this size, and ring it up, take a look at it. I don't know a single professional astronomer who's seen this object.
Chuck, do you have a presentation that you're
Yes.
sharing? Not sharing.
Oh, I'm sorry.
It's okay. You
Okay,
did describe it very well.
Well, hang on just a moment.
Yeah, I was enjoying the
But
description.
I think they do want to see what you were looking at.
Yeah, I'm sorry about that.
That's okay.
I was enjoying the description too.
Yeah, the description was awesome.
Nonetheless, I neglected to share screen, so let's try that again. I apologize, folks. Okay.
Okay, looks like it's coming up.
All right. How are we doing now?
Yeah, just
See 'em now?
There you
Much
are.
better. We're seeing it.
Perfect.
Okay, I'm sorry.
Perfect.
So I'll rush through
No
these.
problem.
This is the furthest thing visible to the unaided eye, reportedly 13 million light years, 7 by 35 binoculars, 70 million light years. A quasar in Virgo with a 4-inch telescope, easily seen, magnitude 13, 2.43 billion light years of light travel time. Here's the quasar I was describing. 2 eighth magnitude stars in the field, a triangle near it, and a little arc of 3 14th magnitude specks. This one, when you see it, the light will have traveled to your eye for 9.6 billion years to get to you. This is even further. This is 12 billion light years of light travel time. And of course, that is a quasar, an active galactic nucleus. And today it's probably a well-advanced elliptical galaxy somewhere 24 billion light years away. Well, with the Hubble Space Telescope, things changed. This was launched, of course, on April 24th, 1990, and had a badly flawed mirror at severe spherical aberration. It was ground and polished quite precisely to within 10 nanometers of precision, but the outer perimeter was too flat by 2200 nanometers. That's 1/11,000th of an inch off. And as a result, the outer parts of the mirror were focusing at a different point than the center of the mirror. The Hubble Space Telescope was pictured in cartoons with the Titanic and the Hindenburg. It was quite a disaster at the time, and taxpayers were not happy. However, we found that what happened that during the testing of the mirror, one little lens in the null corrector, a testing device, was out of place by 1.3 millimeters. And that caused the mirror to be ground to the wrong shape, but precisely so, which made designing eyeglasses for the Hubble Space Telescope quite easy. Story Musgrave has been a frequent visitor in the past to Astronomical League conventions. And in December of 1993, of course, he went up in the Endeavour and installed corrective lenses on the wide field and planetary camera and high-speed photometer, and some other corrections as well on board the HST. And it didn't take long before the HST batted a new record for distance. That was a galaxy called CL 1358 plus 62, light travel time of 12.5 billion years. And today, in whatever form it has, 26 billion light years away. We're seeing the galaxy here, of course, gravitationally lensed by a foreground cluster of galaxies, which is very obvious in the photo. Then the HST in 2014 detected MAX 1149, a galaxy with a light travel distance of 13.28 billion light years. Now we're really getting into the depths of time here because the universe is only 13.82 billion years old. And this light's been traveling to us for most of that time. And today, and again, whatever form this little protogalaxy is, after combining undoubtedly with other protogalaxies, is 30 billion light years away. Well, then GNZ11 was discovered in 2015, another HST discovery, and it extended the range to 13.39 billion light years of light travel distance. But we weren't done. Now it was time to launch the James Webb Space Telescope, and after many delays, on Christmas Day of 2021, the JWST was launched on an Ariane 5 rocket from French Guiana. And the James Webb Space Telescope, as you well know, has a 21-foot wide mirror formed from 18 hexagonal segments. It's gold-coated beryllium. It's light,
Wow.
and the gold coating makes it very sensitive to infrared, red, and orange light, which is exactly what we needed in order to observe the very great depths of time that it was intended to observe, mainly because when you observe very distant galaxies back in time, the light's been traveling for over 13 billion years to reach us and has been stretched. Its wavelength has been stretched as it passes through expanding space. The James Webb can reach 100 times fainter than the Hubble Space Telescope. The Hubble could reach to a Z factor of 11, a redshift of 11, which means it could detect objects whose light travel distance was 13.4 billion light years. The JWST can reach a redshift of 20, meaning it could reach theoretically to about 13.53 billion light years of light travel time. Well, it was intended to observe heavily redshifted galaxies in the earliest stages of the universe's formation, and it did just exactly that. JADES GS 13.0, discovered in 2022, extended the distance to 13.4 billion light years of light travel distance. And meaning that today, because while the light was traveling to us, of course, the universe was expanding, carrying this galaxy again in whatever form it has today to 33 billion light years. But the ground-based telescopes weren't done. The Subaru telescope on Mauna Kea actually beat that record, coming up with HD1 and sextants with a light travel distance of 13.43 billion light years. And that was a record holder for quite a while until the JWST said, no, we want the record back. And on May 31st of this year, just a couple of months ago, the James Webb came up with the discovery of JADES GS Z14.0, a galaxy in Fornax whose light's been traveling to us for 13.43 billion years. That's the current record holder. We shouldn't expect to see much further. We will, but it'll be sort of like watching Mondo Duplantis beat his pole vault record. It will be by centimeters, not by feet. The reason for this, of course, is that we're looking back in time. We're already looking to within 400 million years of the Big Bang, actually less. And so we're looking back to a point in time before the hot gas in the universe had an opportunity to coalesce into stars and little protogalaxies that you have just seen pictures of. So seeing much beyond this, not really likely, but we'll undoubtedly beat the record a couple of times by inches. And I recall someone telling me that this would be a good way to represent how far back in time we're looking. So I'd like you to imagine that the age of the universe was a year, a calendar year, and that we are at 11:59 p.m. on December 31st, about ready to pop the champagne corks. In that case, we're looking so far back in time at this JADES Z14 galaxy that we're seeing it as it was when the universe was at January 7th in the age of the universe. Pretty far back in time indeed. Now, there was a John Kabat-Zinn book, and he was possibly quoting something that was attributable by some to Confucius, who said, wherever you go, there you are. Well, we went to the very earliest part of the universe. with these observations. We've gotten to within 350 billion years, a million, excuse me, just million years of the Big Bang. And there we are. And we're suffused with mysteries as a result of this. One mystery resulted from JWST's Sears project. It detected that some of the earliest galaxies, which should have been tiny little proto-galaxies that were just starting to form from newly formed stars in the universe, were far more massive than expected. Some were estimated to have the same mass as the Milky Way. How is it that in just a few 100 million years, galaxies could form and accumulate mass to reach Milky Way size that quickly? It threw cosmology into a bit of a tailspin, and YouTube hysteria resulted. I'm sure you've all seen YouTube's claiming that the universe is actually 26 billion years old. The Big Bang didn't happen. And these, of course, are clickbait, not based on research. We don't throw out years of research, the COBE, WMAP, and Planck satellite work, the work of ALMA and the Spitzer telescope, Uhuru, Chandra, and other space telescopes. And we don't throw out our lambda cold dark matter model simply because we have a few unexplained holes in our theory. But we do have to ask ourselves what might have caused this. One theory about these massive galaxies, apparently massive galaxies, was that it resulted from bursty star formation, that there was a sudden burst of stars forming that formed supernovas that kicked gas out and then brought it back in to form new stars in a rapid sequence, causing great luminosity to appear in these galaxies. We do know that the universe in the early stages, of course, was much hotter than it is today. Today, our cosmic microwave background runs at about 2.7 degrees Kelvin, but back then, 40 to 60 degrees. Hot hydrogen gas is much more energetic and not really wanting to be gathered together by gravity, which has to overcome that energy. However, if you get enough hydrogen, then gravity does win and pulls it together to form stars. But there's so much hydrogen in these stars that the early stars were very massive. And because of that, they would create great luminosity in these early galaxies and give the impression that these galaxies had greater mass than they actually did. We determine the mass of galaxies, of course, by first detecting the distance to them using redshift, and then by analyzing the spectra of the galaxies to try to determine the types of stars that predominate in them. When we know the luminosity of the stars that we think we're observing, then the galaxy's brightness tells us a lot about mass. We tend to look for something called the Balmer break or Balmer jump, which is a sudden drop-off in intensity of spectra that occurs at a certain point in the spectrum. And it's typical of A-class stars, which are typically slightly more massive than the sun. However, the assumptions we make about the spectra when we observe these distant galaxies is based on our understanding of the Balmer break as we observe it locally. And that may be a false assumption. The Balmer break may not indicate the same thing in these early galaxies as it does locally to us. But then there's another idea. This, by the way, is the Balmer break that you see here, a very sudden drop off in the spectrum, which becomes less when you have cooler stars and also becomes less when you get hotter stars. So if you detect, for example, a Balmer break like this in one of these distant galaxies, it tells you that A stars predominate, and that helps you determine the mass. But again, the assumption is based on studies done locally. Well, there are galaxies out there that exhibit some strange tendrils. Now, this one has hot tendrils. It's a galaxy in Triangulum Australe, and it's called the Jellyfish Galaxy. But at one point in the recent past, the ALMA study found a galaxy 12 billion light years of light travel distance away and detected a huge tendril of cold gas streaming into the galaxy. It was about 300,000 light years long and had about 70 billion solar masses. And it was cold gas, which is ideal for star formation. They determined that this cold gas was adding 500 solar masses per year to this galaxy, which would double the galaxy's mass in merely 1 million years. And these tendrils are consistent with the kind of tendrils we see in the cosmic web, the connections between the galaxy clusters in our universe. So it may be that in the early universe, material, cold gas, was flowing in along these tendrils into galaxies as they formed, causing them to have very high early mass, explaining the observations from the SEER study. But there's a second mystery. The James Webb Space Telescope began detecting something called red dot galaxies. You see it here at the end of the green arrow, and this is what they look like. And these are really oddballs. They have between 10 billion and 1 trillion stars, but they're 1,000 times smaller than the Milky Way. Some of them only 150 to 500 light years across. If we reduce the Milky Way to their size, Proxima Centauri would be in our solar system, and we would be only 26 light years from the Milky Way center. These are only found in the early universe. Now, the problem with determining the nature of these beasts is because we don't yet have good spectra from them. What we do have are images taken of them using different color filters. And what we're trying to do is determine where the Balmer break is, which is spectral information, simply based on where a galaxy disappears from one colored filter to another. And that's very inaccurate. We need better spectra from these objects in order to have a better handle on their mass and nature. But we're left with a question, certainly a paradigm that we don't understand completely. What are these red dots? Why did they vanish? What did they morph into? And why are they redder than the redshift would explain based simply on their distance? So there are many new mysteries out there involved in what we've been able to do with the James Webb Space Telescope. It's opened new vistas and raised new questions for us. Okay.
Wow. Okay.
I would like to say one thing about Bryce Canyon, if I may. There are 275 rooms in that block, and we had 400 people back in 2011. So if you're interested in going,
it's going to fill fast.
Grab those rooms. That's right. Registration is open.
Open online as well.
Put in the link.
It will be. You will be able to register online very shortly. Right now, I think we only have the mail-in registration on the webpage.
All right.
Very good. Very good. Okay. All right. Well, our next speaker is David Eicher from Astronomy Magazine. David has relocated his home to Arizona, where he's able to get much more, clear nights, starry nights. And I know he's glad about that, but there's a lot of new things going on at Astronomy Magazine, and David can tell us about it, but he always gives us some great insight into the cosmos too. So thanks for coming on, David.
Thank you, Scott. I want to correct you though. Actually, technically, Tucson only has about 310 additional clear nights a year compared to Milwaukee. So it makes a slight difference, but not, you know what I'm saying.
Yeah.
So, yeah. The moral, I guess, is if you wait long enough and hope long enough, you get a good sky again. So right now I'm busily painting and building bookshelves, and eventually I'll be all set here. But for the moment,
set up a big party at your house, and we'll come
absolutely
over
anytime.
Properly. Okay.
Stop on by. There's a 50-foot lap pool. You have to swim 20 laps before breakfast, though. That's the proviso. So tonight I wanted to talk about a couple. Let me see if I can share my screen here. Where do I do that? Here I do that. Okay, and I'll get the right screen to share. And I wanted to talk about a couple of, see if I can start the show here. Where do I do that? Here we do that. Okay. Can you see the previously mentioned Centaurus A? I don't know what the big deal is with Steve, a good pal of mine. I can see it. It's right here on the screen with my naked eye. Sorry, it's been
We
a
see it
long
too.
day. Okay. It's
I
been
see it with my
too
naked
long
eye
day.
as well.
Okay. I'm still on Milwaukee time and I'm waking up like at 4 a.m. Forgive me. So anyway, Centaurus A, which we may end up looking like once we do our dance with the Andromeda Galaxy, is there. But I really wanted to talk about, as we work our way northward down to the really good stuff in the south eventually, a couple of galaxies tonight that are far north near the bowl of the Big Dipper, NGC 3718 and NGC 3729, that are relatively close to each other in the sky and astrophysically in space, and they've gravitationally affected each other. They're just a little south of the southern edge of the bowl of the Big Dipper, as we would say in the States. The brighter object, NGC 3718, it's also called ARP 214 in Holton ARP's catalog. It's a distorted barred spiral. It's about 65 million light years away, about 10th magnitude, so it's pretty easily observable as a little smudge, slightly smaller than 3 arc minutes. But in a medium or large size amateur scope, it looks pretty interesting because it has a really strong S shape, as you'll see, prominent dust bar encircling the hub, and a very bright concentrated nucleus. So it's a strange active galaxy, as we would say. It's warped and has a very active nucleus because it is believed to have been interacting with this neighbor, NGC 3729, in the past, long ago. It's about 150,000 light years away, separate the two galaxies. NGC 3729, the much smaller object that has been moving more quickly in space, is a barred spiral also. It's about the same distance. It's a little fainter at 11th magnitude and slightly smaller as well. And it does not appear to be nearly as distorted as 3718. South of NGC 3718, also, if you have a large telescope, is a nice interacting galaxy group, and it's from Paul Hickson's catalog, number 56, which has a chain of distant galaxies very tightly together. They're about 425 million light years away. So here is the obligatory atlas page. I dug out Ron Stoyan's atlas the other night and took a quick picture out of a stack of books. It was a small miracle to find it. But here it is. It's a great atlas, and you can see this is the line at the upper left here is part of the constellation line that goes through the bowl of the Big Dipper. So you can see we're just kind of south of that, and there's some weird galaxies that lie nearby this pair as well, in addition to the Hickson group. So here you can see on the right, 3718, 3729 is on the left, really nice galaxies and showing wonderful details. And you can see the dust band that bisects the nucleus of the larger galaxy 3718. At the top right, you may be able to see the Hickson galaxy group that's not far from the northern edge of 3718. Here's another somewhat deeper image of the galaxy, and you can see a little bit nicer detail there and the kind of star formation that's going in with H2 regions, so to speak, in the galaxy's arms. And you can see pretty well that it's warped. This is a very unusual, almost a twisted barred spiral that has undergone interaction. Of course, the Hickson group is just off to the right edge of this frame. Here's a close-up of 3729 that's relatively featureless. This is from the Sloan survey, and you can see that there's not a lot going on there except for a fairly good ring bar structure. So that's it. I just had a quick couple of suggestions of objects. Instead of shooting the next shot of the Andromeda Galaxy, go out and take some images of these lesser known strange objects. I'll keep this rolling in the future. And we have in November, we're under new ownership now. Firecrown Media, which is a company in Chattanooga. It's based in Chattanooga, but they're employees scattered here, there, and everywhere. They own Astronomy Magazine and most of Kalmbach's previous titles as well. And we're starting to evolve things a little bit. You can see the cover here for November. We have a big feature story by Sten Odenwald about the current state of what we know about our own star, which is the most important one, of course, to us. And we'll have some big changes coming on down the road with astronomy that I think you'll be very happy with if you are a reader of the magazine. So more on that to come. And I have mentioned briefly the last time, I'll mention it again. We're going to have another Starmus Festival with a lot of Nobel Prize winning speakers, astronaut explorers, scientists in all the disciplines, astronomy and elsewhere, and some rock and roll from our friends Brian May and Rick Wakeman and others who will be giving us some music and fun, as well as the stargazing and talks about science. And we'll be doing it this time next spring on La Palma in the Canaries, which has, among other things, the largest telescope in the world, the GTC, which you can see here, which at 10.4 meters edges out the wonderful twin Kecs, which are on the summit of Mauna Kea, of course, as well. So that's all I have right now. Get ready for some big changes coming down the line that I think will delight you with Astronomy Magazine. We hope you can join us for Starmus. There will be more Starmus news coming a few months from now as well down the road. And get out there and go after the little known objects if you can, as well as taking all those images of M42 and M31. That's good stuff too. But there's a lot of other stuff that's out there that has not been observed or imaged nearly so much that I think we can celebrate as amateur astronomers. So I will stop sharing my screen. And Scott, that's all I have for tonight.
Thank you. Well, it's the whole universe, so that was a lot. So,
and forgive me, I'm still, in a, painting, 7 or 8 hours a day and building bookshelves and trying to find places to put 5,000 books. So I'm in total chaos and probably will be for another couple of months before things are completely back to normal.
At least. Yeah. 5,000 books. That's like a whole, that's like a real library. That's not.
Well, I gave away my Civil War library when Chris started college. I donated that to the Grant Presidential Library and I got rid of about 4,000 books there. So,
good Lord.
So that's gone. So it's largely science now, what's left.
Wonderful. Okay. All right. Well, David, thank you so much. Our next speaker, let me just bring myself back on here. I'll stand right next to David Eicher here just for a moment. I just want to feel the ambiance. Okay, that was good. All right, so up next is Ron Breacher. Ron is known as the Astro Doc. He is an amazing astrophotographer and a great teacher, and he's a good guy. When you meet him at astronomy events, you go to NEAF or you go to the imaging conferences, Ron always has people around him because they just want to catch a little bit of his knowledge, but also they want to just hang out with just a fun guy to hang out with. So Ron, thanks for coming on to Global Star Party.
You're making me blush. Thank you. I need an intervention about all the guitars over here.
Yeah, what's with that? I know you're a musician.
I don't know.
Do you collect guitars?
I seem to be.
Recently.
Yeah, I seem to be. But they're all really nice and I use them all. So anyway, thank you very much for inviting me to talk tonight. I really like coming on these global star parties because you always provide the speakers with a theme. And one of the things I like about doing this is those themes really make me think. And so I'm gonna just put up this slideshow, and I called this Understanding What We See, but I'm not really going to tell you exactly how we understand what we see. It's such a personal thing. But that seemed like a good sort of catch-all for what I do want to talk about. This image here is just a work in progress. I've been acquiring this the last 2 nights, and it is the Elephant Trunk Nebula, Vandenberg 142. Next time I'm on the Global Star Party, maybe I'll have a color version of this to show you. So I thought before we get into Scott's theme for tonight, I should talk about paradigm shifts, because that's a term that we throw around and not everybody knows what it means. So I'm going to explore that for a minute, and then show you what really stuck out for me in what Scott provided to us ahead of time. And then I want to show you some of the tools that I've used for helping with understanding, and not just me, obviously. So telescopes, eye in hand, cellulose film, and digital sensors. And then I'm going to give you some examples, just a few examples of how being able to see, particularly with a telescope and a digital sensor, can help us in terms of understanding what we see. So a paradigm shift is really just a big new framework idea that changes the way we understand things in a fundamental way. And I've got a few examples here. So one is that some diseases are caused by germs. That's something that we completely take for granted now. And our treatment of infectious disease with antibiotics, our steps to isolate from each other when we have contagious illnesses, all of those are based on this fundamental paradigm shift towards the understanding that some diseases are caused by germs. We're all, anybody who's watching this show is interested in astronomy and cosmology. So here's another really big idea that was a paradigm shift. The idea that the universe had a beginning. We call that the Big Bang now, and I'm not going to talk about that. I just want to use it as an example of a notion that fundamentally changes the way we think about everything. Because if the universe had a beginning, that means time had a beginning. So maybe there's a point in time beyond which you can't see back. And then the idea that the Earth orbits the sun, not the other way around. That was, if we hadn't come to that understanding, we might have missed the boat on a lot of other important things. Like, how would you get a spaceship to the moon? How would you get spaceships orbiting the sun if you didn't understand those basic orbital mechanics? And the really interesting thing about paradigm shifts is that they always lead to new questions. So if you recognize that diseases are caused by germs, or some of them, which ones are caused by germs? What can we do to prevent that? And so on. There's always questions that come out of these paradigm shifts. So now, don't try to read all this. This is part of what Scott provided us as the theme. I just want to highlight what was important to me. The idea of learning and adapting to new information. That's really important in astronomy. The next one may be the most important of the ones that I highlighted here. The idea, not just that people's dynamic and ever-changing understanding, sorry, what am I trying to say here? We can help people appreciate the dynamic and ever-changing nature of our understanding of the universe. It's not that the universe is changing. It is over time. But it's that our understanding is dynamic and ever-changing, not just the universe. So what we think we know today, we may learn new things that may change all that tomorrow. It doesn't matter. Looking at the sky the way we do as astronomers and astrophotographers, for me at least, it makes it okay not knowing all the answers. The questions are more interesting than the answers. And then encouraging people to stay curious and open-minded. If you think you have all the answers, you're probably oversimplifying things. Information changes the answers every day. And of course, we always want to plant the seeds of awe and wonder. So I use some tools for understanding, and I'm not, like I said, I'm not the only one. Telescopes, of course, were invented a long time ago. 1608, in fact, was the first patent for the refractor. That was by Hans Lippershey. And those refractors were used to sketch. This is the eye in hand. So you can see sketches of Saturn during the 17th century. All of these were made between 1610, 1676. And you can see what the different observers were able to see with the optics that they had available at the time. And by the time you get to Cassini at 1676, you can see the famous Cassini division that we now all crave to look for in our telescopes. And before I was really heavily involved in astrophotography, I used to sketch, and I particularly enjoyed sketching the planets and the sun. And so here is a sketch on the left of Jupiter and on the right of Mars. And that sketch of Mars was made on the night of closest approach of Mars, at least in my lifetime up to that point, and I think ever, was back in August, I think August 23rd, 2003. And contrary to what you'll probably see on the internet over the coming days, it is not going to ever appear in your sky the size of the full moon. That is an internet hoax that goes around every year. So after eye in hand and pen and paper came daguerreotypes. So these were the beginnings of photography, and these are a few daguerreotypes of the sun and the moon. The center one is an eclipse in 1851. So this is all around the middle of the 19th century. Of course, I was using cellulose film, not daguerreotypes, to shoot the moon back in 2008 when I shot this total eclipse of the moon. I used a small telescope. It was an astrophysics 4-inch refractor. And I used a camera, a Canon Rebel camera with film. And it was probably the last real photo that I did with film. And it was minus 25 centigrade out that night. And right after I took the mid-eclipse photo that you see on the right, everything froze. I had to wait for the film to warm up before I could risk rewinding it back onto the sprocket. Luckily, it didn't break. Now, in the middle of the 20th century, up to the middle of the 20th century, so you see that bottom image of NGC 6946. That's 1933. That was shot with a 24-inch reflector and recorded on film. But now amateurs using a relatively affordable equipment and relatively straightforward techniques can get results like this from their backyard. All of these images were taken from my backyard, and they were all taken, you know, in the last 20 years or so. So I thought I'd put together a few examples where it's interesting to understand, to show you how telescopes can help you understand what you see. And this is something that I saw. I didn't see it exactly like this. I imaged this star cluster in 2011. And then in 2013, a friend asked if I would go back and shoot it again for him. And I did. And when I put the two images side by side, one of the stars was missing from the 2013 image. In fact, it wasn't missing. It's still there. You can probably see it when that goes out. It's still there. It's just way, way fainter. And my processing then wasn't as good as it is now. And at that time, I couldn't see that star in the second image. It looked like it had disappeared. And of course, I thought I had witnessed the death of a star, and I wrote to Harvard and reported it as a new discovery, only to find that this is a well-known variable star that had been discovered in the 19th century, WY Cassiopeia. But now we understand what makes this star periodically brighten. I don't have all the details to give you now. That doesn't matter. What really matters is that now with these cameras, we can image this star at 2 different times and really confirm that its brightness is changing quite dramatically. This is another interesting one. So the Crab Nebula is a supernova remnant. And it was seen, so it's been known for a long time. It's been known for more than almost 1,000 years. It was seen in 1054 by Chinese astronomers, and it was recorded. But now that we can take pictures of it with telescopes and we can study its spectrum with spectroscopes, and we can study that central star right here, that's the first known pulsar that was ever observed. We now understand much better what's going on here. This is the shock wave. What you're seeing is the shock wave of an exploded star. That's now, its remnant is now this pulsar. And these gases, mainly hydrogen, sulfur, and oxygen, are really the seeds of the next star that might form the next planet, that might form the next life. The Chinese couldn't have understood that when they saw this so-called guest star, but the paradigm has changed. The Andromeda Galaxy, I've been able to see it in just about everything I've ever looked through in good enough skies, including small binoculars, even 7x35 binoculars. When I was in Costa Rica and it was very high up in the sky, it spilled out of the field of my binoculars. But really, it looked like a cocoon, like a fuzzy smoke patch or something. No detail, no color, of course. Andromeda is one of the galaxies, probably the most important galaxy in completely changing our perspective on the scale of the universe, because that was the galaxy where Cepheid variables were used to determine that this galaxy was far away, distant, much more distant than all the stars that are nearby, 2.3 million light years away. And one of the cool things that we now know, since we know that light has a finite speed, one of the really interesting implications with this galaxy, it's tilted on its side. If we saw it from above, it would be roughly circular. That means that the close edge of the galaxy is much closer than the far edge of the galaxy. And so we're not just looking at one point in time when we look at this galaxy. We're looking at many different points in time, about 100,000 years of time from edge to edge, front to back. This is my most recent image. Scott, you probably got this in your email yesterday or today. If you didn't, you will. This is the Dumbbell Nebula. You don't see it look this way in too many images. I really brought out the outside wings. But this can be seen in any small amateur telescope. It looks kind of like an apple core in a small telescope. In a bigger telescope, it can start to look a little bit like a football, but you need a camera or a very, very large telescope to see any of these fainter wings. The reason why I wanted to put this example up is because of the 3 different palettes that I presented here. So I have a sort of a natural color palette in the center where hydrogen is the red, hydrogen and sulfur are the red, and oxygen is the teal color. But it's much more interesting to present narrowband versions of this where I leave out the natural red, green, and blue filters and just use the narrowband emissions of sulfur, hydrogen, and oxygen. So if you look at the image on the right, that's the Hubble palette. That's the same palette that's used in the Hubble Space Telescope. And I can't tell you what any of the gas mixtures precisely are, but what I can tell you is that everywhere where you see a slightly different hue, it's a different mixture. And if we could look at this broken down into the light that came through the hydrogen, the sulfur, and the oxygen, you would see that those gases are in different locations. And the image on the far left just presents it in a different palette and makes certain things more visible that aren't as easily visible in the other two. The really cool thing about this nebula, though, in terms of understanding what we see and changing perspectives, is the central star here. I know you can't see it in this image, but it's there. It's that larger star in the very center. That's the largest white dwarf that we know of. And now, with our current understanding, we know that this gas was thrown off by the white dwarf as it came towards the end of its life. And that white dwarf now is illuminating the gas. As it cools, it will eventually become a cinder, and this nebula will disappear. And so aren't we lucky to be at this place and time in space-time to get to witness something like this? So, Scott, thanks again for asking me on. If you want to get in touch with me, check out my website, astrodoc.ca, or email me at rbreacher@rogers.com. I'd love to hear from you. Look for my articles in Sky and Telescope. I write occasionally for Amateur Astronomy magazine. And if you want to learn how to make those pictures, check out mastersofpixinsight.com. That's where we teach the processing. Thank you, Scott.
Thank you. Thank you.
Trying to stop my share. There we
go. Trying to stop that sharing. That's right.
I stopped everything else.
Well, on any account, our next speaker was supposed to be Seth Shostak, but we were both running like crazy. Seth was coming back from travel. I was setting up Global Star Party, and we just missed each other. So I'm sure that he'll be on the next Global Star Party or two, and he may be on later on tonight, but on any account, we're going to move ahead in the schedule to Sonali, who was on for the first time on Global Star Party on the 154th Global Star Party, and she did a wonderful job. And so we're excited to have her back. And thank you for being there. And very nice background, by the way.
Thank you. This was the aurora as seen from Omaha in May. And I'm happy to be back. I thought this topic was very interesting. I don't really have slides. It was just a few things that I jotted down as I thought of what I could say. I think the speakers before me have sort of pretty much covered most of what I was going to say, so I will make that segment shorter. I was going to lead with a quote, actually, interestingly, and as a coincidence, by Tennyson from Mort the Author. And I thought, David Levy was going to actually use that, but he didn't. So I'm going to go ahead and use it and say, the old order changeth, yielding place to new. And I think in time we see that again and again. As in medicine, the discovery of germs and other things that changes how we deal with illnesses. And in astronomy, we further our knowledge. In outreach especially, I think it's important because the media picks up on all these new discoveries. And then, someone says, oh, these 6 new galaxies that James Webb discovered, does that mean the knowledge that we have is not correct? Just as Chuck Allen pointed out, we can't just throw out what we have, but we need to build upon what we have. and try and learn something new as to where our knowledge is incomplete and to stay curious. And I think when you do outreach, it's to point out to people that just because we can't explain something doesn't mean our old theories are wrong. It's just that we need to look further and be more curious and open to newer ideas. Just as when you point out Saturn or Jupiter and people ask you how many moons there are, if you don't know the answer, you look it up and look it up with the people surrounding you. Every new discovery is a chance to reach out to people and get them engaged in astronomy. For this, I was going to actually talk about, one of the outreach events, which was a citizen science event about Polymele, where I hope I'm pronouncing it correctly. It's an asteroid around which they discovered a moon, and Lucy's mission is to go past this asteroid. And there was a citizen science, or it involved a lot of volunteers, where actually they figured out where this asteroid occults a star. And using that, they were going to try and figure out about the moon about this asteroid. And this was, I think, in 2023 in February, in the middle of winter. Literally, it was cold, and this path was in Kansas. And it took more than 90 telescopes and 200 volunteers, but they achieved what they wanted to achieve. And I think this is how you involve people, get them excited about science and new discoveries, is to involve them, to point out to people, hey, we discovered this. What do you think happened? Do you think you'd want to be a part of this? And that's how you get the younger generation as part of your paradigm shift, make them open to new ideas, to curiosity, and to take part in these kind of projects. And so every time there's something new, like the deep field of the Hubble, or what, James Webb shows us, I think it's important to sort of use that information in our outreach events. And who knows, I think we'll have more interest in what we're doing. So that was really just a short idea that I had about today's paradigm shift and what's new in astronomy.
I come up with, I try to come up with these themes, and sometimes I struggle. I do, because I'm remembering the numerous outreach events I've been involved with, or people I've interacted with, and it's we don't do the same thing every time. When we're going out and doing astronomy outreach, sometimes we get asked the same questions again and again, but we're also out there exploring, and we're out there trying to guide people so that we can tell that they're kind of on their way, and I think that's and I really admire the people who are truly gifted in doing astronomy outreach, so sometimes I'm just trying to sit back, taking it all in, watching somebody else teach. And sometimes this person teaching is not very experienced, but sometimes just that, I don't know, it's the innocence of it, or
the enthusiasm,
maybe even some of the lack of knowledge, deep knowledge in something that makes it really impressive in the way that they are presenting it to a crowd of people that are getting it for the first time, so, and sometimes some of us come off, maybe we do know a lot about something, or we think we know a lot about something, and we get too narrow and not really, we forget that we're out there to help people. We're coddling people as they're getting their start in exploring, personal exploration of the universe.
And I think it's important to reach out in that sense. Yeah, everyone comes in with a different level of understanding or knowledge when they come to outreach events, and trying to understand where they're from and not making them feel uncomfortable about asking what they think might be too simple a question. We all started somewhere before we got to where we are. And sometimes it's exploring that answer with them instead of telling them about it. It's going in a different way as to make them sort of answer their own question and figure out, hey, I knew this. Make them feel the happiness of finding their own answer is, I think, very, very important, so that they're more open to asking questions and learning and showing them that you're learning with them. Because every time you can have the same question, but if someone asks you that question 5 months later, there might be something new about it. So you learn along the way.
Right.
Anytime
That's right.
anyone thinks that they know everything about what they're talking about, I think you're stagnating at that point if you're not willing to
Yeah,
learn.
they've kind of shut themselves down, I think, a little
Right.
bit. So, yeah, I think that just that kind of in Zen philosophy, they talk a lot about the beginner's mind, and the beginner's mind really is important in learning more about the universe and exploring the skies for yourself, and not just taking what's in a book or taking some expert's opinion or whatever, but starting to form your own opinions and starting to form your own thoughts about what the universe is. Because to me, the word universe means everything, including your own thoughts, including your own imagination. That's part of the universe too. So, I'm not going to get metaphysical on everybody here, but the universe means all.
Yeah.
And all
knowledge
means
is a
all.
journey, so I think we're on this journey together, and we find out answers and build upon them. And as long as we stay curious, open to newer theories, learn from what we learn again. And sometimes you just have to modify that and go forward.
That's right. That's right. And you can, something you touched on before about, allowing people to ask a question. I always figure that if somebody says the words, "Can I ask a stupid question?" I know then, okay, they're starting to learn. They're opening up to you. They're being a little vulnerable and all the rest of it. So we kind of go through this humble stage to feeling a little vulnerable. Maybe even if you are have some experience as an amateur astronomer, but you're observing with someone else, you kind of feel a little awkward sometimes. I experienced this, did experience this with my peers, going, gosh, well, maybe I shouldn't even say anything because they'll think that, I should know more or something, but
I think when people
anyways,
are afraid to ask,
I'm rambling right now, but there's
when people are afraid to ask questions, they inevitably start with, "Can I ask you a stupid question?" And my first answer is, no question is stupid.
Right.
There is no stupid question. It's only a question you didn't ask. And I think just making people feel at ease. And I always tell them, hey, I don't know everything. And if you ask me something that I don't know, I will look it up with you. And I think that is key to outreach. That's key to getting more people in this field, is making them
giving them
that,
some confidence that they can ask the next question, and that they can actually take those steps in exploring, so yeah, very cool. Sonali, thank you for coming on again. It's always a very interesting conversation with you. So
thank you.
Right. So our next speaker is Maxi Falaris. And Maxi, how are you? It's been a little while since you've been on Global Star Party.
Yes, it is. It's been a long while since I was here. I think almost 5 months, maybe.
5? Oh, goodness.
I think
Really? Okay.
it was in March, my last GSP. Yeah.
I see.
So,
I see.
so how are you doing, Scott? How's everybody?
I'm good. I'm seeing the view from, is this your window from behind you, or is this your yard? You've got a beautiful snow-capped mountain.
No, this is a couple blocks down from here, because it's in the, I have this lake. This is
Yeah.
the Potrero de los Funes town. Is a mountain town nearby the capital city of San Luis.
I see.
I moved here a month ago because my wife, she's been here since December of the last year. We've been
Oh,
separated
goodness.
all
Oh,
this time. So in holidays
yeah.
or some long weekends or something, I came here so we can be together. But
Yeah.
2 months ago, I said to my work, I told you that maybe I will going to quit. So now I'm
Yep.
quitting. So
Oh,
I gave them 1 month, of course, to be prepared for everything. So
that's
yesterday, what?
generous. Yeah.
Yeah, yes, because was 10 years of work, so I was very
Wow.
gratitude for them. So I told them in December that maybe it's going to happen. So I have to give this big step. I leave my family in Chivilcoy, 700 kilometers from here, and
Hmm.
uh, my brother, my nephews, my good son is on there, but now I think it's time for a big change. I have to, well, right now I'm still working, still searching for work, but maybe, I don't know, I can study on a university here in San Luis maybe next year, or I don't know. The chances are huge. They opens our doors or are opening. So let's see what's happening in the next months. So besides that, of course, I have my hobby. You know,
Yes.
I, I I I was working, I was preparing mentally, but I also was preparing to stay capturing. I grab a new camera from ZWO. This is a little smaller sensor. It's almost the half of the last one, but it's more it has more details on the pictures. But let me share you what I've been doing all these months, or maybe this background, like I said, is the sierras or the little mountains here, because the in this place for that where you have deserts, and then maybe 200 kilometers from to the west you have the Andes mountains, the big Andes. So
Hmm.
that's our mountains. These are mountains, but more little. Oh, let me share my screen. Sorry, and tell me if the internet doesn't work, because right now I'm using well, here in the province of San Luis, in every corner you have Wi-Fi free. But
I see.
so is it free? It's going to be cheaper. So it's cheaper, it's going to be less or very poor
Well,
quality. But anyway,
Yeah, we say
well,
you get what
Maxi,
you pay for.
yeah, but right now
I
it's pretty stable. We can hear your voice clear.
No, but it's good.
right.
It's good. I mean, you're all the way around the world, so it's good.
Yeah, I think I have 6 megabits from downloading, so
Oh, that's
it's very, very,
probably around the
very low.
minimum of what you need
Yeah.
in broadcasting.
So okay, are you watching the screen?
Your eclipsed sun, yes.
Yeah, the
I tried to catch you, Maxi, but I failed in that effort. I compare what I've taken to seeing your picture once again. I have to go
yeah,
back and
but
work harder.
yeah, but you enjoyed it, and I'm glad that you had it, because I remember it was in the 8th of April, I think, and I was in my work watching the solar eclipse through all the websites and transmissions,
Yes,
and I was checking, of course, and then when I saw your pictures, if you have to leave it, then you have to take picture, but first you have to leave it,
yes.
live it.
And I
So
made sure to do that.
exactly.
It was a wonderful experience. But carry on.
Well, this is my background, my picture. this is me. I'm very happy. This was 3 months ago when I came,
Mm.
and we have snow. You know, I didn't, I don't see snow since 2007, almost 18 years old, 18 years behind when I went to Bariloche from graduation. So anyway, what I want to show you is what I've been doing with the ZWO 533 MC Pro, a NASCAR RCL 200, and the Explorer Scientific iExos 100. Uh, for example, uh, this is from the Corona Australis constellation. We have here a really big globular cluster, but all these detailed clouds, and of course, all these stars behind or in front of this nebula. And I really love the field of view using this equipment. So I want to capture some another objects. This is the small Sagittarius cloud, but I didn't process this yet. This was 2 months ago in Alberti before came here. Uh, this was maybe 1 hour stacking or 2 hours stacking. Was another one that I processed yesterday, the the blue horsehead nebula in Ofiuco. I think it was on Ofiuco or Sagittarius. And you know, here we have it above of my head of Hugo. So you have to capture it all night long. And like you can see, there's a lot of reflection nebula for these stars,
Mm.
and also here. And you know, I was practicing with this gear because I thought, well, I'm going to move out. I had to maybe carry small equipment to continue the hobby. So I was taking these pictures. Also, I went to a sculpture constellation, to the sculpture galaxy.
Nice.
And here, this is unprocessed image. This is only stacking.
Wow.
And this is a global
Lots of
global cluster. Yeah, this is a really field of view to get all these objects. And
Mhm.
well, I think that's, and this is the last one, of course, the Ryofuki Nebula.
Beautiful.
All this with this small equipment, you know, very portable. I only one box with the ASL Ascar ASL 200, the camera, all this the another small gear, and the mount is in another box, and that's all. You know, and I was really happy because I always want to capture this object, and I couldn't. I only could do it with Nikon, but it wasn't the same. So I give it a chance again, and I really liked the work of this object.
Yeah,
So
spectacular.
that night, I was also no, sorry, another night in Alberti, I had to capture some comets that we had. This is I don't remember the name.
Yeah, it looks
Oh,
like you have. Is this an anti-tail? The
yes,
on the
it
plane?
has
Yes.
two tails. Exactly.
Mhm.
You have the comet, the coma, and the two tails. It was almost 15 minutes taking a picture, or a half an hour, maybe, because it was very low above the horizon. But anyway, I could get these details. And also was I had at that moment this Tsuchinan comet that we have now very closing up to the sun. So I give it a chance to capture it again that night.
Very nice.
And this was very,
Beautiful.
very far away. Now it's more near from us, but it's very low from the horizon. So maybe in October, when we have it with the annular solar eclipse in October here, um, maybe we can see it at the sunrise. So this last two was with the ZWO 533 and the f4 8 inches telescope. So I decided to practice with a very small camera from ZWO. It's a planetary camera, and working with the 8 inches f6. So I have a really huge zoom for the objects. It was in my backyard practicing, doing captures for 1 minute maybe. And was the result, for example. This is the same comet, a couple nights later of that one. This is in my backyard, well, in my last backyard in Chivilcoy. And you can see it's the same that here, but very more zoomed. I also went to planetary nebulas from the southern skies. I was really shocked for maybe it was 1 hour stacking or something. I don't remember yet, but doing pictures for 1 minute with a very good guiding. This is the planetary, the Saturn. Uh, Universo Planetario de
Saturn
Saturno.
Nebula.
Yeah, exactly. And when I always want to capture this, but I didn't have very good details on the core and everything. But you can see there's a lot of shapes and the spurs behind. It's incredible with a planetary camera, for taking pictures of Saturn, Jupiter, Moon, something, and 1 hour of capturing. Also, this is a very good one. I really love to capture it. I think it was the Southern Ring Red Nebula. No, but no, I don't think it was. Um, well, the M27 Nebula. This is a very field of view. It's complete field of view. But this object, I have it very low on the horizon. So if I want to have details, it's almost impossible when the sky doesn't goes the scene it doesn't okay. So anyway, I had to give it a try with the 8 inches f6 and this planetary camera, and I have
Very nice.
some details on the core, the small star that ionized the gas and the structures of this particularly nebula. Well, I had to give a try to M16. This is a one-on-one field of view with this planetary camera. I was stunning when I did this in a Bortley 6-7 in my backyard. 1 hour or 2 hours capturing this object only. And I had all the structures of the pillars of creation you know. I don't remember if I use. Yes, I think I use a UV IR filter cut, and that's all.
Wow. It could be a postcard.
Yeah, this. I really love to give it a try again, but I couldn't. Maybe more later, or maybe with another gear. Because I like to compare results doing this in my backyard, and also doing with a very good skies with light pollution and everything. But anyway, to show people what is up there, it's very very good one. Uh, of course, I did practice with the Sombrero Galaxy, and I really love using this camera of the details in the edge of the galaxy, you know, and also kind of at the middle, you know, like there. But it was only 1 hour, very low, or going down to the horizon. But anyway, I had to give it a try.
Yeah, still beautiful.
And this was
You are
the
wowing the audience here, Maxi. Thank you.
Yes. Oh, well, thank you, everyone. This was the little gem nearby the Barnard Galaxy, I think that I remember. This particular planetary nebula, you can see through an eyepiece with a telescope. Even if you are in the pollution area, light pollution area, you can see it. And if you take a picture of maybe 10 seconds, it's going to glow like a very small green ball in the sky or in the picture. I remember when I started to do pictures and everything, I was with my brother Christian, and when we saw this, we thought that maybe we didn't know about sky maps or something, but we thought that maybe is like the colors and the shape. We say, bro, is that Urano or Uranus? Um, and when we checked it, we thought that it wasn't, but it was a planetary nebula. So it's very bright. You can see. I couldn't get more details. Let me see if I can correct more the giving more giving less light, and you can see it's starting to grow the structures of this planetary nebula, but I couldn't get too much. Anyway, I really love to capture planetary nebula with this camera. This was the ZW662 planetary color camera. And then in beginning of July, 1 month and a half, it came what I was looking for, and I thought that maybe this was going to be my principal setup. I bought a ZW585 MC Pro. It has the half of the sensor of, for example, this one is like the half. The inch, the anchor is the same, but it's going to be at this at the middle of the frame. So I start to do some practicing. I did this in my backyard in Chivilcoy. I had that nights or those nights a really good seeing, because I found that my stars are shaped like it was very rhombus. But anyway, with my scope. But anyway, I give it a try. It has the same size of the pixel than the planetary camera, but with a bigger sensor. So the details are going to be almost the same. So you can see here, but this is
That's
unprocessed.
true. Look at this.
Yeah, with the F4.
Yeah.
If you
The
compare
pillars of
this one,
creation right here.
yeah, and this is unprocessed. And this, if with the F6, of course, you have more zoom and everything. This is one-on-one, and this is one-on-one. Sorry. To compare, of course, in this one, you have more focal length, but in this one, you have less. But anyway, you still have some fine details. And of course, the guiding, the sky, and everything, it will be blurred or not your image. And maybe if I deconvolution this, maybe I will have some details. I didn't process this. I don't remember process this, but I really love what I get. But I want to try because I love to capture galaxies, and I give it a try with Sculptor Galaxy. I remember, and the fine details that I got that night, it was incredible. But let me find the pictures, light, and you see. Okay. So what I got that night, it was this. But I didn't like the colors. I have light pollution and everything. But anyway,
Look at that.
I really, it was one night, maybe 3 hours, because it's very late at the night. So I give a try to almost 5 a.m. Or something. And with light pollution, clouds or smog, because I have in Chivilcoy there, it was very cold. It was winter, practically winter. We are still in winter, but now it's getting less, more temperature. So when I came here to San Luis, I say, okay, in Chivilcoy, I was at 60 meters from the level of the sea, 60 only. But here, I'm almost 1 kilometer above the line of the sea, the edge of the sea. So I'm very high altitude. I say, well, okay, I will have more transparency. In the city, I have, or in the small town, it doesn't have too much light pollution. Maybe it's a Berkeley 4 or 5, but it's despreciable when you process the images. So I give a try for 3 nights, and I finally grabbed the better pictures that I have, and I processed the NTC 253, and this was the result here in Potrero de los Funes. You can see the colors that I got, the details of the fine clouds, and the pink or purple nebulosities, like Carina.
There's so many.
There's too much, here in the center, here in this region, and of course the little galaxies that I got on the background.
Oh yeah.
And it's
Yeah, every little
very, very,
dash is a galaxy. Yeah.
yeah. I really love to capture this. It was in my backyard here. I was struggling with the guiding. I have some fine clouds above my head sometimes. Sometimes the scene was, awful. Uh, this stars was like very, very round, like this. So no, it was. I had to trash that. But anyway, when I stack this and I process this, I processed like 3 times, and I really love the shapes of the core, the fine details on the edge, and of course the colors. And this is all the field of view with this camera and an f4. So this tiny is 2.9 the size of the pixel against 3.75 microns of the f33. So it's very low. And the another object that I had, it was this one. This is particularly shocking. I never did this one. I saw it by my friend Germán Bacaro that he did this with his RC, and I had to try it with this new camera. I
Wow.
really love the field of view that I get. This is down the
Is this a
M8.
mosaic?
No, this is the old field of view,
No.
and
Wow.
this is one on one. You know, I to be to tell you the truth, I drizzled this in Photoshop for 2 times of the size of the image.
Okay.
But anyway, I didn't lose details. Maybe a couple of um, the noise it came, but anyway, this place was really good one. You know, it remembers me a mix of M42, the Horsehead Nebula, and the MH Nebula. It has it all. More to the right, it was a, I think, a very small planetary nebula or a very small nebula, a reflection nebula, but I couldn't get it on the stacking. But I had this one, the reflection nebula on the corner, and I really love this object. You know, it's a very good one. Maybe
We
next
love
year
it
we'll give
too.
it.
Yeah,
Well, thank you.
beautiful.
So, well, uh, this is for now. I think I hope that you enjoyed this little resume that I did of 5 months,
Yeah,
almost.
it was
So
great. It was
I
great.
was
Great to
entertaining.
see you.
¿Qué haces, César?
Because
I abandoned you, you know?
yes, you abandoned to me and Nico because you abandoned our province, Buenos Aires. You abandon,
Oh,
but
Yeah,
you don't go to another country. If not, it's another state. It's more in the west, and really, well,
it's like if you are in New York and I went to Arkansas or maybe more Utah, something like that,
more
you know,
like
Yeah.
but
Utah.
unless,
Yeah,
Yeah.
but
he really
it's,
he moved to the Sierras.
Yeah.
He's having more clear skies, more less humid, and we are happy because he's in, maybe he work in the destiny to go to a better place,
Mm,
and
that's right.
the
really,
path of the life, you know.
Like David
yes,
Icke
yes,
arriving in
yes.
Tucson or something.
Yes,
So
yes,
yeah, that's right.
yes. You get the word for
Uh,
your fiance. I know.
Yeah,
For your
it was too much time
yes, but why not
separated.
San
So
Luis? Okay, San Luis. Why San Luis? Okay, say yes. Say yes. Okay, we can move to San Luis. Yes, and I had friends in San Luis, Observatorio de la Punta. Actually, they have a. You visited the mid 16, Maxi? Not yet.
I not yet. I wasn't prepared yet because I want to go slowly. You know, maybe if they
Yeah,
see
yeah.
some work that I
How many?
do,
Only few weeks.
one
You
month or
didn't
maybe, yeah,
have time. Yes, 1 month.
yeah.
Yeah, but
And you know,
you start to produce with the Lexus 100 and the Ascar Maxi.
yeah, the first one shots that I showed, it was with that gear. This was the last one was the with the f4 8 inches, but you know, I grabbed the two equipments here. My wife said, "Well,
Yes, you
we
have
don't have too much. Yeah, we don't have too much space to have. I had to abandon the Dobson in my house.
yes,
Maybe
yes.
in a couple months I will grab it
No,
because
you need to donate
So
to
you
Nico,
still
because
have the house.
Nico is the fan of Dobson.
yeah,
Yeah.
Yes,
This
please.
feels a bit like a reunion because it's been a while since we would close down
Oh,
Global
yeah.
Star Party. Scott just threw me in with the Southern Hemisphere team, and it was an honor because you all were the first ones to show me images from the Southern Hemisphere and especially along the Milky Way. And I enjoyed knowing and seeing some of these things through your live views and your images. Beautiful, beautiful images that are coming along, Maxi, are very, very, very
Yeah.
good. Almost as good as Cesar, but
No, I am
anyway,
not a good
but no,
photographer. I'm
very,
encouraging people to make photography, but
yeah.
not.
And
I'm not the
oh,
photographer.
we're all
Maxi,
learning.
Maxi is the man.
Yeah,
And
if we didn't
you
listen
in
to,
landscapes are amazing, Maxi. I wrote in our inner chat. I say Maxi, the Messi of
Messi.
yes,
astrophotography. The
I
Messi of
Messi.
like,
Yes,
astrophotography.
yes.
but
Our
if
Yes.
Maxi, we are proud of
we're
Maxi.
very
I
Yeah.
proud, but we
well,
learned from Sonali that it's about the images and the outreach and the presentation, and I always enjoyed doing it with you all on the latter half of Global Star Party, the Southern Hemisphere section, where we saw so many things that those of us in the Northern Hemisphere didn't always get to see on a night to night basis. So it was
Yeah.
it's a wonderful. I don't think my beard was as big the last time all three of us were together.
no, I remember
Same
more
time.
larger.
It was larger. Okay, then
Yeah.
it got cut, but
Yeah.
Sure.
I'm trying
Okay.
to bring it back. So
Yeah.
yeah,
The
this
best
is
thing.
a
All
good
right.
moment for me.
So it's time.
Totally, Maxi.
It's
Yeah.
now time for Caesar. Okay. So
Thank
Caesar,
you.
thank you for
But
coming on. Maxi.
I love to share my time with Maxi and Adrian and
Yes.
the entire group, because it's a great group. We
And
know
I'm happy to be
better.
back here. It was a few months that I was here, but I hope that I can continue being here. For now, I will doing pictures of my in my backyard, processing and trying, to
Yes.
answer like a job.
No,
But
you move and I thought, oh, how many times is going to return Maxi to astrophotography? No, you return now, and the
yeah,
best thing is that you don't lose time, and you return to again to make astrophotography. When you start to say, okay, you are making this, and you are moving maybe 2 weeks ago, and really is really great. We really that you have the, how do you say, the emphasis, the energy to make this, because it's very stressing moving, and but you are in a better place. Really, you
Yep.
enjoy. You are approach the place, that this is
yeah.
the best
When
thing.
was the approach of Jupiter and Mars a couple nights ago? I was waiting for my wife to open the garage and everything, but I was watching that and the clear skies that I have here. I saw all the colors of Jupiter, Mars, the Aldebaran star, and it was a really 3D perspective that I got watching that. That maybe in my city with the light pollution, you don't see that. It's more like blur or something, but
Yes,
the
yeah.
fog or something. But in this case, it was clear sky and
And
that
you are
approaching
totally, and you scale 2 bottles more over your
almost, yeah.
this is amazing. You can produce from your own house, your from your own backyard, great pictures. You don't need to go like in the past to another place. Maybe work to 5. You are now, or 4 maybe.
I think it's 5. It's a 5, but
5
depends
is
of
excellent.
the
Yes, yes, but in your hands, 5 is 2 for me. Yeah, it's the handicap.
You know, I have to say I'm sorry, Cesar, because I have struggled with my car because when I quit my job, I say, okay, I have to travel to Buenos Aires to visit you, to visit the the Planetario of Buenos Aires, but I couldn't because my car engine was shot. O sea, se me rompió la caja de cambio,
Oh,
literally.
oh, yeah, yes. I don't remember
Yeah.
the name in English, but it's yes,
Yeah, so
well.
I couldn't travel, and when I get
Oh
repaired,
my God.
I have to travel here. So
Yes, yes.
it was
Don't sell a
very
telescope to repair your car. No,
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 no, no,
no
no,
yet.
no,
No, please.
no. So I want to say you personally, and I hope maybe in a couple of months, if I go to visit again Buenos Aires,
Okay, okay.
let's invite to say hello. So
Okay, yeah, yes, it
Cesar,
will be great. I make a real conjunction with Nico and you, the trio, the trio.
yeah,
Yes.
We have
the
we have
tripping of
Eventually,
our
Leo.
own
eventually it'll
WhatsApp
be a
group.
quad when I make it down there.
Yeah,
I
yes.
still have
Vamos,
to
Adrian,
work.
vamos,
Adrian,
What
come
Adrián.
am I
here.
doing?
Adrian,
I gotta.
what are
Vení
you
con los,
waiting
vení
for?
con los pibes,
Yes.
Adrián, dale.
I
Come with the
Vení con los
guys. Come
pibes.
on.
Sound like yes, come on. Yeah.
yeah. I've been wanting
Really.
to. The wife and
Don't
I
say
are
more.
building a
Don't say
new
more.
house here.
Buy your ticket. Buy your ticket and came to Buenos Aires and we can go. And now,
And you can
You
visit
have an
here.
eclipse. You have an
True.
eclipse this year in
yes,
Argentina.
Marcelo. ¿Cómo estás, Marcelo?
Marcelo.
Yes.
Nice.
And really well, it's something that South Hemisphere, we are preparing the trip to the annular eclipse in Patagonia. Next presentation next week, or well, for the next global safari, I'm going to show how it will be the driving maybe 2,000 kilometers or maybe more to 2,500 kilometers, because I don't I don't buy the ticket. I not I forget, but I say, okay, people, I like to use my telescope in the south, and I prefer going driving from Buenos Aires to Santa
Wow.
Cruz province, and it's around 2,500 kilometers.
Where are you
Two
going to
days.
be?
2 days by car.
2 days, yes, 2 days.
I'm planning to go to Argentina to see the eclipse.
Tell me, Marcelo. Okay,
I'm
I'm
planning to go
going
to Santa
with
Cruz.
Jaime Garcia, that you know
To
to
Santa Cruz.
Jaime. Yeah, yes. We are going to Puerto. I forget the
Puerto
name.
Príncipe. No.
No, Puerto Príncipe is not in Argentina.
El Calafate.
yeah, okay.
You can see from El Calafate also.
But Calafate, maybe Calafate, it can be. But we are going to Puerto San Julián in
San
the coast.
Julián.
Yes,
San
yes, we
Julián
are going to
Port.
Puerto San Julián. Marcelo, if you need something, or if you are going to Calafate, do you have?
I'm planning. I'm choosing. Maybe I have doubts
Okay,
about the Calafate, because last time I saw the eclipse in El Calafate also.
In Calafate. Calafate is amazing. It's in the mountains.
Yeah.
It's great. It's great.
Yeah, but remember that in that place you have clouds. Of course, in the near sea,
Yes,
clouds.
yes. Do you have
Very
more?
cloudy
Yes.
sector.
It's like Maxi says, that if you can go to the middle of the between the mountains and the sea, or in the sea, maybe in this part you have less possibilities of clouds. The last annular eclipse,
remember,
that
it's pointing to. Yeah, remember it's pointing to the west. You know, I think it's 4 p.m.
Yeah. Yes. I think
so
that
it's going.
I think that
until 5
the logistic for the logistic for Puerto San Julián in the east is more easy because the problem with the two cities, Puerto San Julián or Piedrabuena, where I made my military service, it's a place that don't have commercial flights. Yes, yes, but many years ago. The young Cesar Brolo, like a military, is impossible to imagine today. But the problem is that there are small towns that don't have airports with commercials. You need to go to Comodoro Rivadavia or
Yes. Calafate.
Calafate or Rio Gallegos. But we can be in contact, Marcelo, if you need something,
great.
Because
Thank you.
about if I take places for hotels in Puerto San Julián, I contact you for that, because I know that the number of places actually in the entire Patagonia are they're really full. Maybe some small places are available, I don't know, to take a hotel, of course. But
it's only
we
for
are,
one day.
yes,
Many places.
yes, of course, because we are working in this, and it's a pleasure if you came with us, or
I'm
we
planning.
Maxi, of course. Yeah, yes, Marcelo, no problem.
Okay.
Obrigado, Marcelo.
For me, it will be a pleasure to be in Argentina again, because the eclipse in Calafate was fantastic.
See, yes,
fantastic
yes. My
experience.
friend
In
Jaime
2010.
Garcia. Jaime Garcia was in the Calafate, and he had an excellent an excellent experience, and really well, we are working in this. And tonight I have some pictures of the conjunction of Mars and Jupiter, and something that I make with the moon.
You have a conjunction now here, because
yes,
you have
yes,
a
I
conjunction
have.
between Saturn and the Moon.
Absolutely.
Yeah,
Absolutely.
that's tonight, Saturn and the moon. And I still
Yes.
don't know if I will have the strength to get up to see if I can go see it, but we'll see.
Yes. Yes.
Yeah.
But that's
I try to
all over the globe, it'll be close.
Sure. I try
Yes.
to share my screen where is, because I have a big mess. I'm changed
Okay.
to the another screen. Compartir. I think that. Okay.
Now it is working.
Yeah, yes, it's working. Because maybe you can see my WhatsApp, the group of people that we have, and the idea of this is show you first of all the setup that I use in the rooftop of the building to take the picture of the conjunction of Jupiter and Mars. And I put this. Okay, well, here you can see a picture of the moon, okay? A little mineral, maybe. Let me know. I need to see maybe the best way is to watch the YouTube. Okay. Okay, well. Okay, perfect. Well, the difference between this, I try first different pictures that I took and videos of the conjunction. And let me check where is. First, I show you. Okay. You can talk and feel this moment because the problem is that I can find, yeah.
You're looking for the, looks like you
Yes,
almost
the
have.
videos, especially the videos. But now I put the videos. Okay.
They are somewhere in
there. Yeah. I'm trying. Okay. Well, this is the first video that I show you, and this was with the first lights of the dusk in the morning. Maybe this is in Avi is more easy to share. Well, here we have an individual shot of a video of Jupiter with the same moment of the conjunction.
You know, Cesar, I want to give a try with this new camera because the size of the field of view perfectly was with Jupiter and Mars, but the scene was so terrible that Mars and Jupiter looked like a bacteria or something moving in the,
Oh,
in the camera.
yes, and maybe the problem that you have well, I showed this video to show the scene of the morning, and you can see it's not so bad, but maybe you have, for example, from Buenos Aires we have this over the Rio de la Plata and over the
River Plate.
yes, the River Plate. You have less scene because you have a something like this. It's, how do you say, it's more stable because you have water, you have a cool temperature. But if you watch, for example, maybe in San Luis to the east, maybe you have the mountains for the
No, the mountains are what I have in here
more
in
for the
Potrero.
north.
Yeah, exactly. To the east, it's more a farm area with some little mountain, but not too much.
Yeah, yes. Well, this is a processed image that I could make where you have mostly the shape of Jupiter. Of course, the quality is so because the scene was like a say maxi, maybe a little better, but not enough to take a great picture. But you have around Mars and you have mostly wrong Jupiter. But I couldn't make overexposure and process and Maxi, maybe to put the Jupiter with the satellites, but the satellites. But well, this is a decent picture of the conjunction in the same field of view. I used a 3000 by 3000 pixels camera, and I used the telescope that I used was over a EXS 100 mount. I used 4 inches Maxutop telescope, and the focal length of this Maxutop telescope is 1,400 millimeters. It's a huge focal length for a small telescope, worked very, very well for this occasion, where I was enough to have in the same field of view of the sensor both planets. And this was a great thing for me, because I used it as a maxi telescope, a pocket telescope, not a small telescope, but really is so easy to put in the elevator and go to the rooftop and connect all fastly and have a great results. In another way, I'll show you. Sorry. The moon in the night before the conjunction. The conjunction was at around 5:30 a.m. and in the night, I'll show you first some videos of the moon. All is with the same telescope. The Explorer Scientific First Light Maxutov 102 or 4 inches. I love to see the videos. Yes, because you have it was a really windy night, but if you see some results, some final image that I process, you have a great quality, great quality image for a small telescope. For example, this. Look that.
Wow, that looks nice. Very nice.
It's
Very
not
sharp.
the Robert Reeves image, but it's a decent. How do you say 2 weeks ago? You say, okay. But when Robert Reeves, they say, it's a decent. It's a decent. Yes, yes. Coming from Robert Reeves for me was like, oh my God. Well, I make this, and I'm happy to say that the quality, the optic quality of the telescope is perfect for make lunar and planetary image.
Oh, there's some detail I can see in there, Cesar, that shows me you have a very nice image. Robert Reeves has shown us some of the features, and
yes,
you're
and
looking at a few of them.
Yes, yes, absolutely.
You can't get those features with, unless you're very, very steady with a large lens camera, or you've got the right telescope and the right focus. Few of them I'm seeing right now. It's I think it's very, very well done.
Absolutely. Absolutely.
Thank you. For me, I'm really happy that you tell me, and if really, hi Robert, how are you? I am learning for you. But the idea is the idea is that we talk with the people, that is encouraging for the people, encouraging to people, especially to kids, to make affordable equipment, affordable gear like this, and start to make great things, because this is something like everyone can make this, and this is a video with maybe 700 frames, very easy to make. Really, our idea, each Saturday by month, one Saturday by month, we make in our okay, now you can okay. No, I stopped to share the screen. I don't know if it's okay. Dejar de compartir, okay. Ahora sí. Really I'm really inspired. For me, the image like Maxi or Roberts or Adrian or everyone in the Star Party are incredible. The small thing that I can make, it's for encouraging people, and especially teenagers and kids, to use the telescope and take a lot of resources that have from their equipment, but because here you can use a planetary camera, and you can use entry-level telescope like a small Maxutov 4 inches telescope, and you have a great opportunity to encouraging people, to teach people to use a telescope and take results that are astonishing because it's something that you can found in a book, and now you have the opportunity with a small equipment to take a beautiful image. I can make a very fast processing of one of this image. Let me check if I can make one of this. Okay. I will return to the videos. I try to one of the image of the moon. I like to show how this is very easy, and I can make this opening first a video. Here I have the here, perfect. I don't know if we have here, perfect. Sir, okay. Well, for example, here I have one of the videos. I don't make something complicated tonight. Only I use mostly the how do you say, the parameters that you have firstly in the, sorry, I need to go one step ago and explain something. First of all, we can put points for stacking the video, but because all programs that make, you don't take a picture of the moon. You filming a video, for example, with maybe half minute, and in this half minute you have a number of a quantity of frames. Nice again. And these kind of points are for stacking the image of the frame. And we are going to stack. Maybe I will make a disaster now, but I show something like are the process to stacking the video, the frames of the video. In this process, you can make very sharp picture of a video, that maybe the video you have this movement that I show in the video that I shown earlier. And now I'm going to found the image. This is in the same place where I go. I went just I went. Okay, here. And it's something that is now 22. Okay, here. This is perfect. Is this? Okay, I'm opening with another software that is for processing by wavelets. The image that the stacked image from the video. Sorry, it's here. Is a TIFF processed image. Okay. And we can work. Now I trying this software that is a free software and make, look that, working with this tool that is sharpen filter.
Oh, wow.
Look the
That's
difference
amazing.
between, yes, I love
Amazing.
this. And this is the new one because the old one was the Registax, and the same people that make the Registax in the past, they make a new one that is this new software. I can share in YouTube or to show where you can download the software to share, because it's free software. It's very easy to use and really have a lot of different tools to make great lunar and planetary image. Well, here you can work with the denoise tool. Do have another denoise tool later to work, but now my idea is not make a lot of how do you say, a lot of noise.
Oh yeah, just look in that one area compared to the rest of it. It's
yes, it's,
and now it's being processed.
Yes.
That's great.
Well,
thank you, Cesar. Thank you.
It's a pleasure.
Thank you so much. Yes. Okay. All right. Well, we got to see some southern skies through the beauty of Maxi's images, and also through Cesar's images from his balcony, and got a little tutorial here. So it's very cool. Very cool.
Yes.
Okay. But
okay, thank
now
you
we're
very
coming
much.
back up.
Next Global Star Party, we can work more with tutorials, with more tools and details. I'm happy to show this. Free software, very easy to download, to use. It's all free. The auto stacker to stacking the pictures, and the sharpen wave sharp. It's a beta version and work very well. really is free, and with a small telescope, small mount, you can make great things with
Yeah, and a small
software that is
budget.
free. Yes,
Yeah.
yes, and a small budget too. Yes, especially for kids,
Wonderful.
for teenagers, that fathers that are looking for to buy something for them, and old-time fathers that say, oh, you know, my kids really love to have the first telescope, with how they can, what he can do it. And this is the way that I like to show.
I appreciate it.
Well,
Cesar,
thank you very
thank
much,
you very
Scott,
much.
and
We'll
thank
see
you
you on
for
the
the
next
audience.
Global Star Party.
Thank you.
All right. Take care. All right. So we are all the way to you, Adrian.
Yep.
Beautiful image of the Milky Way behind you.
Yep,
And
that was.
is that glow city glow, or is
I
that like
think
the
it's
moonrise
City
glow?
Glow.
Okay.
Of course, yeah, the one to this shoulder is a city in the
Yeah.
distance, and over here there's some more glow that's, you know, it's kind of interfering with the core there. That was taken in the Upper Peninsula, and it was the first time of me looking at a sky with enough darkness to show the structure and color of the Milky Way. Those of us that have seen the Milky Way like that, I wanted to get a picture of it over a nearby falls, and I missed by about 5 seconds of taking an image, because when I got there, it was dark when I got to the platform. The very moment nautical twilight started was the moment I hit the shutter, and I instantly saw the difference in the light, and I missed it. But it's
So
okay.
what was it like for you? You're witnessing it, you're seeing it visually, right?
Yeah, and just trying to
So
capture what I see.
what was
Yeah, so
what was running through your mind?
I absolutely talk about that. Was the first time I saw the Milky Way, and I don't think anything was going through it, because everything was blown out of it. There was nothing there but, wow, this is amazing. And then the second thing was, I want to capture this. So I got to get the camera set up and, you know, do what I can. And, you know, got it focused, and, you know, the actual image, I'll go ahead and see if I can find that. I'm going to move my screen so it looks like I'm turning my head. That's because I want to share. I was also going to share with Cesar. He just told you how to get the moon. And you know, I definitely love Cesar's work, but unfortunately, I do beg to differ sometimes with the camera that I had kind of shown briefly. That's the instrument that I use to do some stills directly of the recent blue moon. But let me show really quick, because we'll continue on the theme. That was a very important Milky Way sighting, if you know, we'll call it that, for me, because and here it goes. It's a wasteland of an image, but the sky itself, this was not done with a modified camera. And you can kind of tell, because some of the regions that are normally pinkish in the modified images are not, but absolutely all the detail was coming out. This large dark nebula and Hercules here. Go in and you can see Barnard's E. When you zoom in, sometimes it takes a while for the focus. Look at the Bitarazed here. Look at Barnard's E. It popped out. A lot of the parts of the image, like the coat hanger here, looks just like a coat hanger, that I love looking for when I take these images, because I do it from an astronomy standpoint. Delphinus showed up here, and we're just getting into the Cygnus rift. Alberio is probably buried somewhere. I think it looks like a single star. If it's not this one, this double star here. Usually when you take a wide angle image, you don't get the two stars you see that comprise Albireo. I was even starting to get some of the galactic bulge region here, and there's a SH227 seemed to begin to form. This is 61, so I went 60 seconds. So of course this is blurred out, but a minute of imaging and probably the one of the more balanced images that I've taken. I continue to take some unbalanced images. Here's me trying to combine it with that and of course you get this sort of panoramic effect. I tried combining that image with the this image of Cygnus here. I don't think the veil came out, and you can barely see parts of it right here. I think. But without that HA modified camera, the pieces and parts of some of the HA regions weren't as prominent, but it was amazing to see it. And I think that's the whole goal of everything that I do, including when I go somewhere in image and daybreak. Now, this is not the sun for those. This is the moon rising underneath this fading Milky Way here, because we're hitting nautical twilight, and the image that I took make the color a little brighter than it actually was. But you're catching sort of the line between astronomical twilight and nautical twilight is some of the things that I would attempt to do to try and capture different areas or regions or different things that the night sky does. Because as you can sort of see in this, there's all sorts of things, from a tree that no longer looks like this, the branch broke off. There's the falls that I was going to image from, and I think, yeah, this is what I ended up with. This was the I just missed it shot. There's a small Sagittarius star cloud. And I don't know, Matt, I'll leave the info up for those that want to know the specs on how the settings. This happened, basically seconds, the light changed and we were in nautical twilight, and there's the Milky Way fading. So the image I would have had would have been darkness, lots of stars, and the Milky Way angled this way with the waterfall. And I may have had a chance to even, by this time, here's your shot. Milky Way is now gone. It didn't take long from that point. So last vestiges of the Milky Way. There were clouds here too, and there's some of the stars that are still visible, and there's another angle where you can see the full part of the falls, and it's winter. I was a lot more fearless when it came to imaging, and I would go out middle of winter, icy roads, and take these images. So really quickly, so that we'll get back to some of those. Now, about the moon, and of course, Robert Reeves will share his wonderful images, but you can see I have a string of pictures that I took, some handheld, some not so much handheld. When you handhold the moon, and I don't know if you could see that, you handhold the moon, most of the time you're gonna miss. This is from last night. That's a miss. But sometimes it's almost like lucky imaging. You hold it still and you use image stabilization, you get a hit. I judge hits by looking at this region, and I don't know, I will admit to not knowing exactly the regions, but Robert Reeves called this, and you'll see it in a couple of other images. It looks a little bit like Thor's hammer. It's a I think there's a mount. It's kind of a mountain or a plateau that resembles Thor's hammer. To me, this resembles the boot of Italy. But that actually isn't the sharpest that you can get it using using the same camera and maybe getting a spat of lucky imaging, you can get even sharper in that region. And see now, of course, with a little bit of process, you can start to see some of that structure here. That was processed a certain way. I took this image. It's a bit processed, so it may, and when it comes in, but now look at some of the detail. This is a 600 millimeter lens, handheld, but leaning up against a car. Still didn't quite get it as perfect as you'll see it if Ron goes through this particular region. But you can get very close. It just and of course you see some of the noise. So compared to Cesar's image, which was very clean, you still have to contend with some of the noise. But what you do, if you're taking the image, of course, the further back you move, the less that noise comes into play. And then you push the saturation just a little bit to see the differences. You can do a mineral moon. All the imagers know that if you push the saturation all the way with this thing, you get what's called the mineral moon here, which these elements, iron, titanium, it was found that those elements really do exist there. And somehow sensors oversaturated point those regions out. Now, the way that you and I see the moon is more like this. And that's if we have, with our eyesight, actually, that's more like that. Black and white. You might be able to detect the slight difference in color in I think this is Mare Serenitatis, if I'm not mistaken, or this one. My moon knowledge, that's what Robert Reeves is for. As he comes on, he will, and I try to take notes, but I sometimes fail. I just know I like to capture it, and the region that I love on the moon is the one where my alma mater, University of Michigan, Hadley's Rill is over here. Cesar actually had it imaged beautifully where Apollo 15 landed, the all University of Michigan, and I do believe they were all Air Force Falcons too. I think Worden's one of them. I used to know the names.
Irwin,
Worden,
Scott.
and Scott. All U of M graduates, and I believe all Air Force graduates, if I'm right, Robert.
It's the only all Air Force mission.
Yep. So they flew and landed here in Hadley's Rill, which, if I'm not mistaken, it's this region here. And were the Apollo 15 crew. And of course, the other Apollo landing sites are here, 12 and 14, not far from I do believe not far from this crater. I know this is Copernicus. And you had 11, 17, 16, 12 and 14. Apollo 13 landed or Apollo 14 landed where Apollo 13 was supposed to land, and then Apollo 15 over here. So that's the moon. I want to end my segment with what was up in the sky not too long ago on let's see, this is August 11th and 12th. We were treated to a display, and I'll see if this image, okay. We were treated to an auroral display when we were just out trying to see meteors. And we even have the streamer. It's either Steve, I think it's more SAR, which I had captured the name of it. I will see if I, nope, that's Steve right here. So the names, if I have them. So this one talks about, it was given an acronym of Steve, and it should be up here. Alan Dyer, I guess, is credited for finding it. But there, it's a different display. It's not quite Aurora. And there are some of you in the chat right now, some of you watching, that are yelling at your screen telling me what it means, because you remember I had this copied so that I could read it off, but cannot find it and want to, let's see here. So the glow was called Steve here. This is this article. Thought I had a better article of it that describes what it looks like in my photo. And these are artifacts of a badly done panorama. Alan Dyer actually saw this photo and thought I had captured Steve because he saw this. Another imager said it's probably SAR, which lasts longer in the sky and lasts longer than Steve typically lasts, about an hour if you're looking at an auroral display. And SAR lasts for hours. And that's what this particular band did. It stretched all the way to this region where the Milky Way is. And let's go ahead and grab, let's see here. So here you have, there's the Perseid being upstaged by all of this auroral activity and me aiming up at the Cygnus region. This is with the camera that's not modified. And let me find, I had the picture with the camera that was modified, and to my dismay, it is not here. I will find it, but let's go with this one, which is an image while the aurora was raging. And there you have another Perseid. One of the images I really like that I found recently. As Scott knows, I like to paint tranquil scenes when it comes to imaging, to the point where when I do, this is on the other side, there's the little Steve or SAR, which I tend to believe it was more of a SAR. I thought this was a artifact in my shot, but it turns out it was not.
What is the difference, Adrian?
The difference seems to be that SAR lasts longer in the sky and is closer, like this shows up closer to the aurora itself. You know, it stretches, the band stretches. And I think there's a difference in actually the colors are a little different. With Steve, sometimes comes a green picket fence phenomenon, and there was none here. Whereas it's essentially like this disjointed band here. It's described as that disjointed band. So that is, and to best of my knowledge, that is what it is. And of course, after I'm done presenting and I look it up, I will probably type it in our chat so that it can be sent out. I will finish my presentation with a time lapse. I finally did a time lapse of aurora, and you can see, now you'll see people come to this bench. They were here to look for Perseids. I've put this to music, but of course I muted that because, you know, there can be some copyright issues. But there you see what we saw during our auroral outbreak.
Very nice.
When the,
very nice.
and you can see some planes, a lot of Perseids were going through at the same time. So it was a very beautiful sight. I do believe the couple spent the moment to actually notice that there was aurora there, and then they resumed their search for Perseids, and there were many, but I know a lot of people were distracted and turned to aurora. So
very good.
Yep. So that is
All right.
it, and I will go ahead and stop sharing.
Thank
And,
you. Wonderful. A great ending.
Yes.
Thank you very much, Adrian. And our next speaker is Robert Reeves.
And here I am. Let's see if I can.
Thank you. Thank you,
Yeah.
Adrian.
Thank you for having me. And Cesar, sometimes you can take a moon picture with a camera. It isn't as detailed as the telescope.
Yeah, you need a Maxutov telescope, Adrian. The list is never full. The bucket list in astronomy. Yes, a 14 inches like Robert Hub.
Yep. But when you're on a budget, well, you can do pretty good with a fairly simple, it won't show it anymore, with a DSLR or mirrorless with a large enough lens. It's a good start, or we'll call it budget moon photography.
Okay. Well, with that, we will give Robert Reeves, our man from that delivers the postcards from the moon.
Alrighty. Well, thank you for having me back on.
Thank you.
The theme of the show, I think, was shift in cosmic paradigms, how we see things differently in the universe now than what they thought years ago. Well, of course, huge changes in astronomy just within our lifetime. Black holes, dark energy, all that kind of stuff. Just science fiction stuff just a generation ago, but now it's pretty much mainstream. Well, the same with the moon. The moon has undergone a tremendous change in how we see it and understand it within our lifetime. And indeed, since we went to the moon, since Apollo went to the moon, it's kind of strange to think that we didn't have a pretty good handle on the moon before we sent people to it. But in fact, about 99% of what we know about the moon now is from ever since the mid 1960s. So during my lifetime, the moon evolved from nothing to what we know today. So let me see if I can get my screen share. I do not see an option for screen share at the bottom of my. Can you activate the screen share for me?
I cannot activate it.
No,
I can deactivate it.
Well, it does not show up on my at the bottom. The usual button that I click for screen share is not there. Usually the host has to allow it.
Let me see. Let me try this. Do you see it now?
No. Participants, chat, react, share. There it is. There it is. It's there now. Okay. Boom. There we go. All righty. You are screen sharing. Hello. Here we go. My standard screen. So since most of what we know about the moon has come about since my life, since I was in high school, even. I mean, the Apollo program came to its fruition when I was an adult. I was in the Navy when Apollo 11 landed. And, that's about as adult as you can get when you're in the middle of the Vietnam War. So prior to that, I was in high school, grade school, back when we first started taking the initial shots at the moon. And gosh, I remember back in the 1950s, the science fiction movies like Destination Moon by George Powell, still an excellent movie, even though it's, clearly pure old science fiction. But those were coming out when I was young and could understand the concept of the moon in the sky and the astronomy. But like I said, it's just since I've been an adult that we've really understood the moon. So prior to that, everything we knew about the moon is what we could see in a telescope or calculate with pen and pencil. No computers back then. All of the great mathematicians who understood gravity and mass and everything back in the 1700s using Newton's laws of physics and so forth. They could calculate the masses and the motions of the moon and the planets, but they couldn't tell what they were made out of, where they came from. In fact, one of the basic premises of the entire Apollo program going to the moon back in the 1960s was to determine where did the moon come from. And surprisingly, we still don't have a definitive positive answer for that. We have theories. We have theories that are widely accepted, but we still do not definitively know where the heck the moon came from. So let's very briefly go through a summary of our understanding of the physical moon. And one thing back in the 1950s, I remember the Nobel laureate Harold Urey, world famous geochemist. He was adamant that the moon was this time capsule of primordial matter from the birth of the solar system. Well, we now know the moon is not the primordial object that we thought it was before the space age. The moon is made of rocky material that has been melted and heavily modified by both exogenic and endogenic forces. Now, those are fancy words to say the moon has been smacked by meteorites, asteroids, and comets, and it has had volcanic eruptions from within the moon. So it's far from the time capsule of pristine primordial material that formed at the birth of the solar system. It has been heavily, heavily modified since then. And get the next one. And now there were two conclusions that were drawn about the moon prior to the space age. Now this came about back in the late 1950s. Gerard Kuiper had a lot to do with it, and so did William Hartmann, that the moon underwent a huge bombardment about 500 million years after it was formed. And that's where we see all the great basins that later filled with lava and formed the Maria, which formed the face of the man on the moon. And also volcanic activity began on the moon about 700 million years after it was formed and was prevalent for about 1 billion years. And that's when the face of the man on the moon evolved from these volcanic eruptions. Now, after 50 years of intense research, since we have gone to the moon and brought back samples, the Apollo missions, the Luna missions, now the Chinese Chang'e missions to the near and far sides, bringing back samples. After 50 years of research, the moon remains lifeless. In the lunar samples that have been returned, no living organisms, no fossils, and no organic compounds have been found. Now, the lunar evolution process through the accretion of smaller bodies, melting and impacts, have left the moon with a crust about 60 kilometers deep and a uniform lithosphere reaching about 1,000 kilometers below the surface. Below it lies a partially liquid core, and we still not know for certain if the moon possesses a small iron core, although I strongly suspect that it does. It's small, perhaps about 100 kilometers in diameter. Now, the oldest rocks on the moon are the 4.6 billion year old light colored highlands known as the Terrae. Now, a curious thing about some of these rocks, Apollo 16 recovered an anorthosite sample that has been dated as 4.4 billion years old, one of the oldest known rock on the moon. And the really cool thing about it is, I know the guy who picked it up, General Duke, lives about 25 miles up Interstate 35 from me up in New Braunfels. And I've run into him at conventions here and there. And it's kind of cool knowing that he picked up literally the oldest rock on the moon. Now, the youngest rocks on the moon are as old as the oldest rocks on the Earth. So now the Earth and the moon formed from the same source material. That's the leading theory right now, which I'll go into a little bit deeper here shortly. And the Earth and the moon evolved similarly, but the moon is depleted in iron and volatile elements. The lunar rocks formed at high temperature events with little chemical reaction with water. And evidence of the earliest events that occurred both on the Earth and the Moon billions of years ago now are only seen on the Moon. That's because the Moon has no atmosphere, no water. Earth, on the other hand, has a very dynamic atmosphere. It has plate tectonics and weather that constantly erodes and modifies the surface. Now, lunar rocks can be categorized into three broad types. Volcanic basalts that erupted from the interior and formed the dark regions of the Moon, we call the Maria. Anorthosites, which are the lightweight material that floated to the surface of an early molten moon. And breccias, which are, excuse me, there's a cat trying to climb on top of my other monitor. Newest addition to our family. This is Olivia, and she is very rambunctious. And like I said, the third category are breccias formed by the mixing of these other rocks that are crushed together by meteorite impacts. Now, after the molten moon solidified, it was blasted by thousands of asteroid impacts during the late heavy bombardment. This was a period about 3.8, 3.9 billion years ago that coincides with what we call the Nectarian epoch, and I will explain that shortly. Now, the largest impacts created the basins that later flooded with lava to form the Maria, which we see as the dark spots that create the face of the man in the moon. And the primordial moon was much closer to the Earth than the modern moon. When the moon formed, it was about 10 times closer than it is now. And it has been slowly receding away from the Earth at the rate of about 3.5 centimeters per year, which basically means that in the time since Neil Armstrong set foot on the moon and today, the moon is now about 2 yards farther away. So, curious thing is the crust on the far side is thicker than the near side crust. And it would take a while to explain that, but I'll just leave it as that. That's the way it is. And most volcanic flooding on the basins occurred on the thinner crust near side. There's no large regions of basalt on the far side. The higher density basalt within the near side basins displaced the moon's center of gravity, allowing the moon to enter a synchronous rotation and keep the same side always facing toward the Earth. So, and over billions of years of its existence, the moon has been blasted by countless meteorites that have crushed the upper layer of the crust into a mixture of dust and rock we call regolith. And because these impacts can excavate rock samples from deep within the moon's crust, by selectively picking up these rocks by trained geologists on site, it's possible to analyze the interior, the chemical composition of the interior of the moon. And why is my advance? There it goes. Whoops, advanced too much. Back up one. Now, I was saying shift in thinking about the moon just within my lifetime. I remember very heavy debates back in the mid 1960s, 64, 1965, even as late as that, about whether or not craters on the moon, something as basic as a lunar crater, was of volcanic origin or was it of impact origin? Even as Apollo was flying to the moon, they were still debating this. That's how recent it's been since there's been a universal acceptance that craters on the moon were created by impacts. And they're ubiquitous all over the moon. And it's kind of hard to look at them and not visualize that they were created by an impact. But then again, our modern thinking is skewed by the fact that we've been told this, but they just never look like volcanoes to me. I always thought they were impacts. Now, I mentioned the change in thinking and the moon just since the Apollo era. Back when I was in high school, the Apollo's missions were flying. There were 3 different theories about how the moon came about. Like I said, one of the premises of sending Apollo to the moon was to try to determine how the moon was created. And strangely, it may be the last question we answer about the moon. But back then we thought the moon was either created elsewhere in the solar system and gravitationally captured by the Earth. It was created as a twin world of the Earth at the same time, or it spun off from the Earth, fission of our planet that was spinning very rapidly after its initial formation. Well, after the Apollo program was over with, about 10 years later, a general consensus began to form that the moon was created by the collision of two worlds. A hypothetical planet that we call Theia, about the size of Mars, occupied the same region around the sun that our proto-Earth did, and the two worlds collided about 4.6 billion years ago. And computer simulation after computer simulation shows that in this collision, a moon will form from the cloud of debris. And the early moon was certainly molten. This accreted coalesced ball of heated rock, the continuous impacts, the radioactive elements within it provided enough heat that the moon melted. The entire surface was a global magma ocean. And I'll give you a clue. Keep an eye out for the next several days on the Astronomy Magazine online edition for my article about new results from India's space mission last year that heavily implies that the early moon possessed this global magma ocean. But in this postulated magma ocean, the heavy radioactive elements sank, the iron sank, the silicates floated to the top, and it took millions of years for the moon to solidify. And when it did, then it went through the various periods of geologic time. Now, these were not determined until after the Apollo missions. This whole lunar dating scheme is very recent in the chronology of lunar studies. Prior to about 4 billion years ago, back to the formation of the moon, an era we call pre-Nectarian. Then I mentioned the late heavy bombardment, where the moon was, and the Earth and all the inner planets, heavily bombarded by asteroids and comets. This was about 3.8, 3.9 billion years ago. Very brief period of time in the existence of the moon, but it significantly altered the face of the moon. Then the Imbrian epoch after that, where volcanic flooding created the face of the man on the moon. And then the 2 billion years, the Eratosthenian epoch, where there was the cratering that occurred on the moon after the Maria were formed. And then the modern era, about 1 billion years ago to the present, the Copernican epoch. And we identify all craters formed in this period of time by the fact that they still have a ray structure around them. Rays will fade after about 1 billion years. So if you see a crater with a ray, it's a young one. Now, looking back with the hindsight of what we know now, post-Apollo, digesting everything that we've put together throughout the 400 years of telescopic observation and sending spacecraft to the moon, this Don Davis painting summarizes what the moon looked like during the Nectarian epoch, about 3.8 billion years ago, before volcanism flooded its surface, and very heavily cratered, huge basins on its face. And then the Imbrian epoch, where volcanic flooding filled the low-lying basins with basalt and created the dark features that make the caricature of the man on the moon. And then the modern epoch, Copernican epoch, where the craters that have ray structures, the rays still survive. So in a nutshell, you can go out later tonight. The moon will be rising a little bit past full moon, so it'll be similar to this view. And you can look up with your eyes or just a pair of binoculars and see the face of the man in the moon, the dark regions that are flooded with basalt, and look on that and realize that you're looking at something that we have just recently understood. 100 years ago, it was completely unknown how this came about. But now we can look at the moon with our own eyes and see the evidences of how it was created. The giant round maria, or the basins that were the giant impacts almost 4 billion years ago, and then the volcanism that flooded it, and the craters that peppered its surface. We can see some of these with our naked eye. So you can look at the moon and see these features that we've just very recently begun to understand. So just like the cosmology is undergoing tremendous paradigm shifts with the acceptance of black holes, acceptance of dark energy, acceptance of quasars, neutron stars, these very science fiction-like entities that we only dreamed about just a generation ago. The moon is also evolved right before our eyes. We have an understanding of it now that we did not have when I was a young person. So it is evolving right along with the rest of astronomy, and we still have a lot yet to learn. We've got to go back and poke and dig around in it some more, and there's still much to be learned about the moon. So we're running a little late, so I'll cut it off right there and say I've had a lot of fun chatting about the moon again, and hope to do it again sometime.
I appreciate it very much. I was chatting with the group here, and I have now dubbed you the David Attenborough of the moon.
Well, I've been called
the
a
reason
lot.
for it, it's not only how knowledgeable you are, but it's your voice. It's your voice and the way that you describe the moon, and the obvious love and to hear someone that understands something as well as you do about the moon, and to hear it live is really amazing. And we really do appreciate it. There someone else that has your book, I think it was Jeff Wise, maybe. I might have gotten that wrong, but when they're reading the book, they can hear your voice, and that's really cool.
That's wonderful. That's wonderful. I really appreciate that sentiment. And like I said, I've been called many things in my life, some which we cannot repeat here. But that is, I take that as a marvelous compliment. David Attenborough of the moon.
Yes.
I'll wear that badge proudly.
Okay. All right. That's great. Okay. All right. So we are going to move from the United States down to Brazil, and we will have some time here to talk with Marcelo Souza. Marcelo is he is the editor of Skies Up magazine. We are getting ready to do some changes to the magazine and evolve Skies Up to address some of the more contemporary and needed types of articles for our audience. And so, Marcello has done a wonderful job. You've been editing the magazine now for, is it 2 years? Is that right?
Yes.
Yeah.
I think
All right.
since
So
the
he always
pandemic
gets
period,
together
since the
a
pandemic
great
period,
collection of contributors. So
and the next
yeah,
magazine is
but
near to be launched. We already have the article.
yes. Wonderful. Wonderful. Well, I'll turn it over to you, Marcello. Thank you so much for coming on.
Thank you very much for the invitation, Scott. Ever is a great pleasure to be here. Thank you. And for me also is an honor to participate because before I saw the presentation, fantastic presentation. It is wonderful to be here with all of you, only experts of astronomy that make wonderful presentations. Last week I was in Uruguay. I was invited to participate in an event in Uruguay about tourism, and my participation was about astrotourism. I share here my screen,
Hmm.
and it was a fantastic experience there because I was representing our astronomy group, the Dark Sky Rio de Janeiro, because I'm the director, also the Dark Sky Rio de Janeiro is the first and unique until now Dark Sky chapter in Brazil. And before I show what the event that I participate, we need now to be looking to Corona Borealis, to the T Corona Borealis, because it's near to appear de novo there. Now, the prediction is that probably will appear in September this year. You have many different predictions. This was before I talk, part of what I will say now is in an article published by the Sky at Night magazine.com. And I also have images from AABSO. And here is in 1945, you have the outburst, de novo, in T Corona Borealis. And you can see here that first we have a pre-outburst, pre-eruption dip here that was in May 1945. And then we have the outburst in 9 February 1945. Something is wrong here. If it's 14.6, it's wrong. It's 1946. And is one happening. Then for the experience that you have in what happened in the past, we can make predictions for the new one. Here, I think that is better. You can see here the pre-eruption dip on May 1945, and had here the Nova, the explosion, in February 1946. Then we had another one again in July. Then for this experience, and what happens, what we know that is a binary system. We have a white dwarf and a red giant. Then what happens is the material from the red giant is transferred to the white dwarf. And then the white dwarf, with this material, they have intense nuclear reactions, and then the brightness of the white dwarf begins to be higher, and then you have this, you can see as a nova in the sky. And these are the results. We had a pre-eruption, what we imagine a pre-eruption dip from March, April 2023. And if it will happen in the same, we have the same periods from what happened in 1946, then we have the probability that from May until September, we had a new nova in the sky. Until now, didn't appear, then we have the probability that September will be the best moment to see the nova, or today, or tomorrow, we don't know. But I have also another prediction that this can only happen next year, in 2025. Now we need to look to the sky every day, take pictures of T Corona Borealis when possible, and see if we have we have a good luck and we register the nova in the sky. I know that many people in the world are doing this, and let's see when it will happen. But this is the moment. This was the event in Uruguay. Is a meeting, Ibero-American meeting of tourism, and one of the topics was astrotourism, that is growing fast here.
Yes.
Many people are talking about this here in our region, in Latin America now. In Brazil, because we have the first dark sky park of Latin America is located here, near our city. And we participated in the recognition of this first in December 21st to 2021. That was the recognition. Here was the presentation with the members of Spain, a representative of Spain here, and the two representatives of Uruguay in Tourism. And you had the experience to show what we did, what we are doing, what we are planning to do in the near future. Here are the team that participating in the Tourism moments at these events. And it was fantastic to share experience there and know what he is been doing. Here my presentation showing what here the presentation from Fernando that he is director of the Dark Sky Uruguay. Talk about the effects of the light pollution. You me. And we also had the opportunity to make the observation of the sun. This is the main square, which was very cold there. For me, it's very cold. The temperature was 5 degrees at night, 3 degrees. For me, it's very cold. Here in Brazil today, in my city, it's 30 degrees. Then I travel from 30 degrees to 5 degrees at night, 3 degrees Celsius at night. This was the observation in main square of this small city. It's a small city in Uruguay. And here was our experience at night. We organized the Tourism event during the Ibero-America meeting. Here is Fernando and Carlos from a group of astronomy in Uruguay, in the dark sky of Uruguay. And you have some telescopes, binoculars, and this was the place. And I had the opportunity to see, it was the sky was clear without clouds, and it was possible to make fantastic observations. There. Here, here is a short video showing the sky. They turn off the lights. This was only for we make it register, but they turn off all the lights, and it was possible to make observations. And now we call tourism of stars also, not all tourism and the tourism of stars here. And it was a great experience for me. Now I have other group. It was very cold, very cold. I'm showing this picture for me. And when I arrived here, I participated in other events in our cities. This was an event in a school. Here is a Explorer Scientific Telescope. Is a Maxitov. And we had more than 300 kids participating. This night I had also the equinox here. A lot of kids. I have the equinox and the Explorer Scientific Telescopes. And who was helping me was my youngest daughter. She now is helping me in the events as she is here. And she was moving the telescope to the moon when necessary. He already knows to do everything. Here at the telescope. She's helping me in the events. She is 80 years old. 80 years old only. And she likes to show the
She likes it. She really she's
yes,
happy to observe the stars.
Yes, she showed the images also here. Was finding the moon. And here the moon from the equinox also, in the tablet. We use a tablet to show the images. It's a fantastic experience. a traditional telescope and a modern system together.
Yes.
This was fantastic. And everybody was in the line to see in the old telescope, in the old system. They love to look at the eyepiece there. I saw this in this event because we showed the moon in the tablet, but most of the people, I think all the people was in the line, all the kids, teachers, everybody that was there, or stayed in the line all the time to have the opportunity to look at the telescope. Here is our observatory. Here with the telescope from the Our Sky Network. We organized 2 events there, and the August 30 we have another event. Now we have 2 events per month at this place. It's a astrotourism event that shows the observatory, and we have a walk in the forest, inside the forest. We go and to see the sky there. Here we had a presentation to talk about astronomy, about our experience, and from there we go with all the people that are there to look to the sky in a dark place because you don't have artificial lights there. Here's a short video showing the experience. Going to the forest is a forest near the ocean. Then the trees are not high trees, are very short trees. It's a different kind of forest. I don't know how you call in English, but here we call restinga here in Brazil. That is the forest that is located near the ocean. You have small trees. Here is the observatory. It is second event. They are looking to the sky there. And here, everybody shows image of the moon. I'm also showing. This was the image I took yesterday here in the super moon event. That's all the press here in Brazil was talking about this. I was using the Equinox to take this image. Yeah, the event in my university yesterday. And now I will show some information about the eclipse. I know that Caesar will talk about the eclipse, but here it will happen in October 2nd. And you see here that Chile and Argentina will be the best place to see the eclipse. The south region of Argentina. And I was looking because in Argentina it will be 5:40, I think, the moment of it will be annular eclipse of the sun. And I was concerned because of the sunset, but I saw that I now have the information. I know that the sunset will be after 7. Then we have time because last time was near the sunset when I needed to go 1,000 meters high to see the eclipse because the Andes, mountains.
Wow. Yes, it will be this year. I think that it will be a colder time because this winter is maybe longer than another ones. But you have a long day in the Patagonia. That is very interesting.
We are going to the summer, no? We have
the spring. We are going to the summer.
Spring from spring to summer. Then
yes. October 2, we are going. And it's a really a big trip from Buenos Aires driving, but we like the adventure to go to the Patagonia.
And this cheap also because the flights are very expensive.
International.
I'm trying to go away from my family, but it's very expensive.
Yes, it's for us too because the flight to Rio de Gallegos from Buenos Aires is really, it's like in Brazil. You have domestic flights of
Yes.
3 hours, or United
Yes.
States 3 or 4 hours, but are domestic flights. For people
Yes.
talking with people from Europe is you are you are crazy.
You
They
change the
cross
country, go to another
three
country.
countries.
Yes.
Yeah,
And
yes.
here are the totality.
Yeah.
Yes,
Here
you have
Puerto
here
San
in-
Julian is where
Yes,
we are going to
you
be.
are going to. No? El
Yes,
Calafate
yes.
is here. You need to travel probably
Yes,
50 kilometers to go to totality.
yes, but the roads, if you take the three national road, it's a single road, but is in good conditions. The inner roads, like a 40 road from Calafate going to the north, are more sometimes more maybe not asfaltada, we call it. So
Okay,
no the
but
typical.
Cesar, let me ask something because I saw here a city called Perito Moreno, but you also have a glacier here that's called Perito Moreno, but it's in the
Yes,
south,
they
the
are two
glacier.
different. Yes, it's different.
Because I
The
visited
local.
last time the glacier here. That's fantastic. A blue ice. That's something
Yes, yes,
unbelievable. But when I saw Perito Moreno here, it's the same
yes.
name, but it's a
Glaciar Perito
different place.
Moreno. Yes, it's different. The place of Perito Moreno, the town, Perito Moreno, the glacier. Yes, it's two different. Yes,
Okay.
and it's more near to the Calafate, the Perito Moreno glacier,
Yes, yes.
because
I
it's the
visited when
Santa
I was
Cruz
there.
River. Yes, where say Comandante Luis Piedrabuena is where I made my I had my military service in my young
It's
years.
very near here.
Yes.
Very near.
Small towns in Santa Cruz or Gobernador Gregores is in the middle of like a desert. It's very interesting. It's so different, the Patagonia for us too, that is so windy, so open.
But
The Patagonia too.
I saw that
I prefer sometimes I think in Florianopolis or we love.
Rio de
We are
Janeiro,
going
Rio de Janeiro.
Rio de Janeiro. My daughter was in Rio de Janeiro this last vacations, and she loved
Okay.
she said, I need to go to live in Rio de Janeiro. Yes, for us it's amazing because our beaches are cold weather or cold waters,
What?
and yes, you feel very very cold in water when Brazil is amazing for us when
But
we visit the beaches. The beaches are fantastic.
you'll be
We
welcome.
can
When you come to Brazil, let me know. You'll be welcome here.
yes, with the same road, that with the same kind of kilometers that I go to the Patagonia beach in Puerto Madryn. I can go sometimes to Florianopolis, driving from Buenos Aires. 2
Oh,
days and 1.5 day. We go to the typically talking with Scott too, that Argentinians can go to driving to Florianopolis and another city. Maybe you remember much better than me.
Porto Alegre is near.
Porto Alegre, Florianópolis y Camboriú. Camboriú, yes.
Balneário
Yes.
Camboriú, in Santa Catarina.
Santa
Yes.
Catarina, yes. Very near to Argentina, totally.
Yes. Scott, this was my presentation. Thank you very much for the invitation.
Thank you very much.
I hope I have the opportunity to visit again Argentina in October.
Yes,
Thank
I told with the people from the hotel, Bahia Hotel, if they have some places, and I advise you if anything that any news about this, Marcelo.
Thank you very
I
much,
contact
Scott.
you, no problem.
Thank you very much, Scott. Ever is a great pleasure to be here. Thank you very much.
You're welcome.
Okay. Okay. How about how about our audience? Maybe they can go too.
Yeah, it will be fantastic to have, because the eclipse is something that I think that
Just a joke, but
everybody
hey,
needs to see
for all of
at
you who have
least
not
one
seen the
time,
Southern Hemisphere, you have
in
to
life.
go.
No?
Yeah.
Are you coming to see? Are you
Yeah.
coming, Scott?
I hope to be back down again. You know, once you get a taste of the Southern Hemisphere stars, you always want to go back because it's so beautiful. It is the ultimate.
Yeah.
So
Yeah.
Yes, it's
okay.
fantastic.
Thank you. Thank you very much. Okay, so now we are going to go all the way to South Asia, to Pakistan, where we will meet with Yumna Mahid. She is a pioneer of space education in Pakistan. The reason of her drive is that as a schoolgirl, she was told that there's no place for her in space. So she decided to create her own. So, Yumna, I'm going to bring you on now.
Hello, everyone. Hi again. I hope you all are doing well. I just want to ask Scott, can I share my screen?
Yes, you can. Let me bring you on first. Here we go.
Yeah, I need to put my slides.
Thank you very much for coming on to Global Star Party. I know it's very early there.
It's okay.
Yeah, we're separated between Arkansas and where Yumna lives is about 10 hours of time on the clock. So, but thanks very much, and we look forward to this presentation.
I still can't see the option of sharing my screen.
You don't see the option. Let me see.
I know Robert Reeves didn't see it at first, but I know it's at the bottom. Participants, chat, and then the green share screen button. So if you're not seeing that, I don't know what's
You
going
might
on.
need to widen your Zoom application.
It's like restricted. Request the host to record settings, stop the video, and return to default.
Try it again.
Okay. Can I refresh?
Refresh, and if we lose you, come right back on. Okay.
Okay.
Yeah, Rob was saying try Alt S. I think Yumna's gonna refresh. I guess there's a key. You can use Alt S to share screen if you don't see the share screen option. That's actually a great suggestion, Rob. But we'll see if Yumna. Okay, Yumna is back. And
yes,
I'm gonna go on mute and let's see, because you've shared your screen before, Yumna, so I'm sure it should work.
Yes, and I don't know why I still don't have it. But Scott, I just sent you my slides on email. If you can do that directly, yeah. Where's Alt?
Yumna, try Alt S.
Alt S. I'm actually trying to found Alt key on my Mac. And okay, Control and S. No, it's just downloading the page.
Okay.
Oh, working. That is so strange.
And I need permission to access your PowerPoint.
Can you see my PowerPoint?
No, we
No, I
can't.
need to get access from you.
Oh,
It says request access or switch to an account.
yeah, that's strange. I did give you the access. Quite strange. I'm so sorry, guys.
That's okay. You gave us your story. Struggle is nothing new for you to overcome. You have had to fight worse
That's true.
than just a computer issue.
This is the least.
This is you will figure it out. You have had to have the patience just to do astronomy in your country, and now the computer will not hold you back for long. We'll find a way. I think sending the presentation to Scott is one way to do it, or telling us, till we can see the share screen sign. I think that anything you tell us, we are going to listen.
Have you requested, Scott? Have you sent any request?
Here, let me do it.
Hello.
Yeah, I'm here.
Can you have you
Okay,
sent?
so I sent you a request.
Okay. Now I see it. This is such a basic thing, and it works like in milliseconds. And today, when I really need it, it's not like it's loading and loading.
No, I was doing my presentation and couldn't see directly in front of me, so it's okay. I was trying to describe phenomena for aurora, and it was right in front of me, and I couldn't read it. And then I found it, and now I can't. I was gonna say what Steve and SAR meant while we were waiting for your presentation to fire up, and now I can't find it again.
So strange.
It's just the email.
Yeah.
It's loading to just give him the access. That's so strange.
Yeah. Well, we have a wonderful audience, so they'll bear with us, I think.
Oh my God, it's taking all the time that I have to speak. That is so wrong. Maybe
Here, let me try this one more time.
Okay.
This will be a different email address. Okay. So I'm sending the request right now. Let's see if this works. Now, you just got back from
Cape Town.
Cape Town.
Yep.
Africa.
Yes, just a few days ago.
Well, so you travel all over the world doing this stuff.
Yes, and believe me, this time was, oops, it was, the experience in Cape Town was really good, but the start was unfortunately quite ugly, and I had the shortest presentation ever. And maybe you can see this file, Scott. I just compressed the whole thing to make it easy because I don't know, for some reason it's
okay.
It's loading.
Why don't you just try? Yeah, compress it, email it. Okay.
So yeah, for those that listen to me stumble when I did my presentation, Steve is strong thermal emission velocity enhancement. And I'm pretty sure that's not what I imaged. I imaged SAR, which Let's see. I think it's a strong auroral arc.
I hope the slides work now, but I will just start without the slides.
Stable
It's a
auroral
lot on
red
the way.
arc.
So yes, I'm really sorry, everyone.
Oh no,
that the slides are
these
working.
things. These things happen.
Yeah.
You're solving the problem by sending the presentation to Scott, and it will get underway soon. I'm sure we'll get working, and I'm sure when you test after this is over, it's going to work perfectly, because that's what computers do. I've worked on computers all my life. I know how that goes.
So it's just 3 days ago I came back from Cape Town. It was so I went to Cape Town for International Astronomical Union General Assembly. It's a conference that happens after every 2 to 3 years. And I was also invited to speak at different schools in Cape Town as a part of their National Science Week. So I left Pakistan at 5th of August, and after my layover in Abu Dhabi, I was supposed to be in Cape Town on 6th of August, but unfortunately, I missed my flight and I ended up staying 2 more days in Cape Town, which was really difficult one. Oh, that's the old one.
Is it?
Scott, that's the old one.
Oh, okay.
Yeah. I just sent you the new one, but it's okay. You can show this as well. It's completely
Can
fine.
I show that one as well?
Yeah.
Well,
It's
this is all of your accomplishments, and those that missed you at the last Global Star Party can now get acquainted with just what you accomplished.
Yeah, look at this. Look at all these awards and achievements. It is amazing.
But after getting my flight to Cape Town, we went, and when I reached there, the experience shifted and it turned to be something really good. I was invited by Living Maps. If some of you know Steve Sherman from the Facebook community, I was invited by him to speak at different schools. So unfortunately, I missed the first 4 days of GA. But my first day at the GA was really fulfilling because I get to attend a keynote speech from astronaut physician Dr. Mae Jemison, and I could relate to her so much because the values she carried during her journey and the interests were quite similar, and the top most important one were becoming an astronaut and the love for dinosaurs. So that's what I found common among us. Then I get to experience the colorful, beautiful culture of Africa, which was amazing. I never thought that Cape Town would be so beautiful and so colorful. And one day we went to actually a robotics club. It was an after school robotics club. The weather was not in our favor, but we had a small group of kids, and I shared my life journey with them. What are the lessons so far that I have from almost over a decade of space education? And the most biggest highlight of my tour to Cape Town was I met Professor Brian Schmidt, the astrophysicist and the Nobel Prize winner, Vice Chancellor of Australian National University. I was not intent to, but I unintentionally memorized his entire keynote because every single word he said in his keynote was extremely relatable. He was not there to tell us that what he has done, what he has accomplished, and how many awards he has won, but he was there to tell us that what I have done, how I did it, and what I did wrong, and what we shouldn't do. So he was extremely down to earth to share the real, you can say the negative aspects of his doings and telling us, advising us that this is not a wise decision and maybe have a plan. The biggest advice he gave was, if you want to have an impact career in astronomy outreach, we understand that it's a great field, but don't do it blindly. Do it planned. Because when we are doing something with sheer passion, most of us do it like just blindly. We just listen to our heart and we just go straight, and just like me, in the end we end up in some sort of problems, most importantly the sustainability part. So yeah, he told us that if you want to do it, it would be great, but at least, do it planned. I also get to meet a lot of faces that I knew from social media, and they were good friends, but I never get to meet them in person. So it was my first IAU GA experience. And then comes the few really cool parts. I did not notice that I am actually going to the southern hemisphere when when I was planning and when I was boarding. But when I landed in Johannesburg and I experienced the extreme cold, I realized that we are in the southern hemisphere now. So I requested a few friends who took me to see the night sky. I just wanted to, just checklist that I have been to the southern hemisphere and I have enjoyed the night sky over there. It was extremely cold, very windy, and a little dangerous route, but the view was really beautiful. Um, my two of the posters and one oral presentation were accepted at the IAUGA. Due to missing the flight, I could not present my posters, but I did my oral presentation, which was about culturally relevant role models for girls in South Asian countries. Um, I would love to present that in the next Global Star Party. And yeah, again, we went to some more schools. Um, sorry. Oh, we got the slides.
Yes.
Yeah, we went to some more schools. This one was Fluorescent School in Cape Town. It was a little in the outskirts of the Cape Town, a public school. Uh, Kids were amazing. They were very shy to ask questions initially, but once they started, they had so many questions. So it was a great experience. Short time, like 40 minutes, but I really enjoyed the session with them, and I requested them, since they had so many questions, I requested their teacher that they can write all their questions, each student on a small piece of paper, and submit it to their teacher. And the teacher will send me the photos soon. I will be writing letters to all these kids sitting behind me, and I'm gonna mail those to Cape Town so that they can have their answer, on a small card on a piece of paper, which would be a space souvenir for them. Maybe I will print something, maybe, but I just want to give them something that they can remember um, for a longer period of time. And the next part, where, yeah, the next few photos are again from kids who were asking me different questions, and I was just so happy. The questions they were asking were, the first question that I asked was like, what it is like in Pakistan, and I was like, it's 46 degrees Celsius in Pakistan, and I just went back to another temperature. And yeah, there were so many questions, and I'm looking forward to the submission by the teacher. And another fun part is in the next slide. I never I'm somebody who's very afraid of animals, and I love dinosaur, and the biggest reason is they don't exist. Um, but for some reason, I was so attracted to penguins, and I was really glad. I was very excited that I want to see the penguins, and we went seeing penguins. We went to see the beauty of Cape Town. Um, we had a weekend during the IAUGA where we were just given our time. There was nothing on schedule by the conference, it was just 2 days for all the attendees to explore South Africa, to explore the beauty of Cape Town. And I really had wonderful experience. I think that was my first tour where I did something other than the conference as well, because most of the time when I go to conferences, it's like 1 week and it's entirely the conference. I don't get time to explore the culture or the city as well. But this one, I really enjoyed it. It was a great exposure, and I realized that one should actually do explore the city as well when I travel. And yeah, that's pretty much it. One thing that Cape Town was amazing. In all means, the food was good. I could find a lot of Muslims, a lot of halal food options. But one thing that I just want to say is that whoever goes to Cape Town, just be a little careful, because everybody tells you that it's not safe in the dark. That is right. So you better come back to your place before it's too dark. The rest, it's a beautiful, amazing place. And the last slide, the patch that I have in my hand, it's my official mission patch, designed by a Pakistani Air Force pilot. And now this particular patch is with Professor Brian Schmidt. I gave him the patch as a souvenir. That particular patch had traveled with me to almost 4 different countries, and I just handed it over to Professor Brian Smith because I was so inspired by his journey. Yeah, thank you. That's it.
Okay. Wow. Thank you. Thank you, Yumna. So, when is your next adventure? You mentioned your
Yeah, my next space adventure is in October, but I am not sure about it, because Italian visa. I got Emerging Space Leader Awards by IAF, that is International Astronautical Federation. So this year the conference is happening in Milan. Um, it's a fully funded scholarship for me. It's a very big deal. I got it after volunteering with them for almost a decade, but unfortunately, I'm not getting visa. The situation right now for the visa appointment is crazy, and agents are asking like for $250 instead of $100 fee of visa appointment. So they are just asking $250 for their share, and then the 100 fee, that visa fee, is something that is totally separate. So due to the chaotic situation at the embassy,
it's $350.
yes, that is a lot in my currency. So it's chaotic, and yeah, so there are a few other Pakistanis coming to the conference, but they are coming from other countries. They have either their student visas or dual nationalities, so they are getting their visas done, or a few are actually spending $300, and it's crazy. They are they are able to get the appointment. I'm not even able to get an appointment, unfortunately, because that's a lot for me. It's crazy, but I was looking forward to Italy, but until yesterday, then I got to know that this is it, and my emails to embassy or using all my network is not getting me the appointment. So I just sort of gave up, unfortunately.
Yeah, don't give up. Don't give up. Keep trying. So something may happen. So
Oh,
okay.
yeah. I hope
Well,
so.
thank you. Thank you, Yumna. And we look forward to having you on the next Global Star Party. Take care. And thanks for getting up so early to be with us.
Oh,
That's
it's
right. I
okay.
forget that
good.
time is so different.
It's
I
early.
wouldn't have been able to make it, Scott. I'm sleeping in. I'm sorry. Can't do it. Thank
Right.
you.
Welcome.
Okay. So we are moving on to our next speaker. This is let me bring on. Here we are. Rob Gross. Rob, you are down, you're a professor down in Texas, is that right?
Instructor in Florida.
Florida. I don't know. Hey, I'm from Texas, okay? So
close enough. Down south.
Anyhow, that is close enough. So, but you're an astrophotographer, and yep, and you use astrophotography in your instruction to the class. Is that correct?
Sort of. I mean, I teach physics and I show them my photos. It gets them sort of interested in that kind of thing.
Okay. Well, let's I'll let you have the stage
Let
here.
me share my screen.
Sure.
It should work.
Yep,
we can see it.
That is strange. Yeah, we have some people that are able to share,
and some share, and some people can share. Okay, so yeah, so I'm just gonna basically describe sort of my journey so far through astrophotography. And I do astrophotography in a high Bortle zone with fairly cheap equipment too. So that's the thing that a lot of people think they can't do decent astrophotography in high Bortle zones. And most people think they can't do decent astrophotography without a expensive setup. But my setup's fairly cheap. It's about $2,000 more or less for everything. So I'll just tell you how I started and where I am now. All right. So first of all, a little bit about me. As already stated, I'm a university physics instructor at Florida Atlantic University, which you probably never heard of. Actually, you might have heard of if you follow basketball. They made the Final Four 2 years ago. But anyhow, so I started astrophotography during COVID. I needed another hobby. I have a few hobbies, but I need another one to keep busy. So I began with just a DSLR camera, a Nikon D750, sorry, and a Sigma zoom lens. Originally started on just a tripod. Eventually moved to the IXOS 100 mount after a couple months. But using a DSLR to zoom lens is pretty hard to do without anything else. I didn't have any other hardware. I wasn't using any computers. It was just basically a camera with a lens on it on a mount, and everything about it was sort of a pain. So over the years, I sort of upgraded into my current setup, which I'll describe in the next slide, probably about a year and a half ago. So that's when I think I really started getting astrophotography. I mean, when I used the DSLR and zoom lens, obviously I was doing some astrophotography and I was processing the thing, but I really started to advance quite a bit once I got my final setup, which I have now about a year and a half ago. So, I've been doing it more or less for 4 years. I took about a year off, so it's probably about 3 years, a little less than 3 years. I've really been, like I said, serious about it for maybe a year and a half. So I'm not really an expert on it. I'm sort of an intermediate. I don't think I'm quite a beginner, but I'm definitely not an expert. So some of the things, that I talk about, maybe someone else has a different way of doing things, but I'll just describe what I do. So let me just show you. Let me just skip a slide here. So this is where I'm in a condo, by the way. So that's why I needed a fairly portable setup. The IXOS 100 mount. Wow. Yeah. Oh yeah.
This is your bright lights here.
Yeah, it's even worse than that. So I need a portable setup to get up and down the stairs. You can kind of see the stairs on the side over here. Yeah, so I can't use a big portable. I mean, so they came up with strain wave mounts a couple of years ago. But I started, doing this stuff before the strain wave mounts. So I used the IXS 100. And yeah, and I image, in this courtyard. And there's actually this bright, so you can see it right here. I don't know if you can see my mouse that well, but there's a bright floodlight right there, which is like right in the way. I mean, you can see the shadow. So it's not a particularly easy place to image from, but it's basically the only place I can image that's close to my condo. All right, so let me go back. So I run everything off a power bank because I can't run a power cord, down. This is from basically my balcony, more or less. But I can't run a power cord down there. So everything has to run off a power bank. As mentioned, I use an IXS 100 mount without the AZ adjuster, by the way, because it came out when I bought it. There was no AZ adjuster, but now there is. But I got used to basically nudging it back and forth to get the polar alignment pretty much. I use the AT60ED telescope, which is a 60 millimeter refractor. I think it's a doublet. It's an APO, but it's not even a triplet. So with the 0.8 reducer flattener, it's 288 millimeters of focal length. So it's not a long scope by any stretch. But then again, I can't really do a long scope with the setup I have. And I use a Player One Saturn, which is a 533 sensor, which is actually passively cool. It's another thing. I'm in Southern Florida and I don't use an actively cooled camera. So it gets, the sensor temp, especially in the summer, is 32, 33 degrees Celsius. It's not that cool. And Leah tri-band filter for basically everything, even broadband. I shouldn't really be using it on broadband, but I have so much light pollution that it actually helps a bit on broadband.
That you need.
And a cheap mini PC to run the whole thing. So, with the mini PC, I can polar align, I can plate solve. It makes things much easier. And again, it's in Bortle 89, South Florida, in a courtyard with bright light. So what I do is I use a blackout curtain to block that brightest floodlight, as you can see kind of here. It's not the best picture, but there's a curtain here. It's a blackout curtain, like the blackout curtains you can get, for your home. I just put it up on a tripod, basically. It's two different tripods I hang it from. So that blocks out at least that bright light. And then I kind of, try to shoot away from that light when I can. So basically south and east is when I try to image. Because over here, towards the light is basically west. And then towards this wall here is north. So I can shoot basically south, which is the opposite direction, and east, which is over here. And it works out pretty well. And I use Nina as my acquisition program. I actually don't guide. I have a guide scope. In fact, you can maybe see it. It's really hard to see. There's no contrast here, but there's a guide scope here. I tried guiding when I first got my mini PC, but it was weird. There were weird things going on. So I just abandoned it for a bit. I'll eventually get back to it. So I don't guide. So I shoot fairly short pictures, subs about 30 seconds, sometimes 15 seconds for particularly bright objects, but usually 30 seconds. Almost all the time it's 30
If
seconds.
you're getting sharp photos and it works, you
yeah,
do that until
better,
you have,
which I'll get to. But
absolutely.
And all my pics are fully calibrated with bias dark and flat. So I have to take the darks every night. The good thing about South Florida, it's hot, but I'm close to the ocean. I'm about a mile away, and that regulates the temperature at night. It really doesn't change that much. So that helps me when I take darks. Because if the temperature changed a lot, that would be a problem with darks, but they don't. So the darks work pretty well. All right, so I went through that.
You probably get pretty good seeing conditions too.
Yeah, I have good seeing most of the time.
Yeah,
which is good.
Yeah.
So I use Surreal. So the other thing that I do is I don't use fairly expensive or expensive software either. I mean, a lot of people use PixInsight, but I try to see what I can do without spending a whole lot of money on software. So I use Surreal, which is free. I don't know what the audience is here, but Surreal is free. I use a script that I modified a bit. It's pretty easy to do. When I do multiple nights, I stack every night just to see what I have. And then if I have multiple nights of calibrated pictures, I just basically stick them all into a sort of master folder. And then I stack the pics, the calibrated pics over multiple nights together, manually sort of in Surreal, but that's pretty easy to do. And then once they're stacked to process, I use Gar Expert, which is free for both background extraction and also denoising. So they upgraded GrayExpert, I don't know, a few months ago to include AI background extraction, which is basically where you put the background sample points is done by AI. And it works pretty well. Sometimes it doesn't work that well, so I do sort of the manual way of doing it. But the really nice thing is about a couple months ago, they introduced AI denoising, which actually works really well. It works as well as some commercial programs you can buy, and it's free. So basically, I apply some denoising in the linear image, and then I move everything back into, so once I background extract, remove some of the noise in GrayExpert, I move it back into Sorel, and that's where I do color calibration, I remove green noise, I do deconvolution. I separate the stars with StarNet, which is also free. So far, everything I've done, all the software I use is free so far, from what I said. Oops, something just happened. Okay, so yeah, once I use StarNet, and then I start stretching in Sorel. So Sorel really got better about a year ago. They introduced general hyperbolic stretching, and they always had arcsine, but they introduced GHS stretching in the same module as arcsine stretching. So the GHS is really, I think, pretty powerful for processing both the starless image and the star mask. So what I do, everyone does things a little bit differently. What I do is I use tiny stretches in GHS. I basically just stretch a little bit at a time, and you basically, there's a highlight protection slider that limits how much you blow out bright areas. So with that, you can really do sort of a high dynamic range photo with just, one set of subs. You don't need to do, I think, you don't need to do different sublens to get a fairly good
It's a good
HD.
technique.
Yeah. So it's really good. So yeah, so basically I use GHS to stretch the starless and the star mask. And I sometimes use AstroSharp, which is another free program, to do a little bit more deconvolution. I don't always do it though. Sometimes I do it. Depends on the picture. And then the only thing I really pay for is Affinity Photo, which is sort of an alternative to Photoshop, but without the subscription fee, right? It's just a one-time purchase. So there's some free macros in there that James Ritson made. I think he works with Serif, which makes Affinity, just for astrophotography, and they're amazing. They actually do a really good job at tweaking the final picture. I also have some more sometimes paid apps. So I sometimes use Noise Exterminator, which integrates into Affinity, AstroFat Pro, and Topaz Denoise. These are all basically things to kill noise in various stages. And I also use Nick Effect plugins, which are free too. So most of the stuff is free. I do pay for some of this stuff, but it's a lot cheaper than PixInsight and using the full suite of the Exterminator apps, which can be pretty pricey. Yeah, so I do use Topaz Denoise, which is a little bit controversial in the world of astrophotography, because a lot of people think that the AI algorithm introduces sort of hallucinates and introduces artifacts. But I find if you're very careful with it, you don't overdo it. I think it works pretty well, and it cleans up.
I would agree with you. I use Topaz Denoise for the Milky Way stuff that I do and some of the images I showed. And I think part of it, how your data comes in, and then if you actually tweak it, don't just let it pick the settings.
Oh, yeah.
Lately it's been picking better settings for the type of imaging I do, where I don't have all these little bitty lines and overdone sharpening in there. So I think they're getting a little bit better when it comes to the Astro stuff.
Yeah, definitely. And you got to do everything manually. I don't do anything. I don't have it do anything automatically for me.
Yeah, I'm
That's
getting to
about
that
it.
point myself.
Yeah. So I'll show you some pictures after this slide that I've done. But yeah, so I'm still learning. I've only really been doing it for a couple of years. Yeah, I'm definitely going to get guiding going probably in the fall. It's too hot now to spend like an hour outside just trying to fiddle with guiding. But when it gets cooler, I'll probably get that going so I can get a little bit sharper pictures. And when I get guiding going, I could probably do a slightly longer sub lengths because I really should be doing a little bit longer to increase my signal noise ratio in the end. And, you know, down the road, I'll probably get a mono setup at some point, but that's probably a few years away. So anyhow, it's some of the most recent images. That's
very
the
nice.
veil. It was 540 minutes of integration time. That was actually from last summer. That's the California Nebula, 260 minutes. Lagoon and Trifid, that's from actually this summer and last summer, integrated data. 30 minutes. It's a horse in a flame. 300 minutes, 5 hours. Crab Nebula is a little bit tough with my setup. Rosette.
Yeah, Rosette's nice.
Dumbbell.
I see you're getting some of that the wings that everyone's been trying to do now for the dumbbell, and you're getting them too.
It's tough though. I need more hours on that thing. Crescent. Yeah, I have more, but that's the sculptor I did this summer.
And you've got, do you know this cluster you've got on the other side?
I forget the name of that.
I forgot it.
Markarian's chain. I forgot. M55. That's easy because it's a star. Because it's a star cluster. But yeah, that's pretty much it.
Yeah, still have to have round stars. It still has to be sharp, you know. So
yeah,
yeah, excellent.
Yeah,
excellent work.
Oh
Now,
no, go ahead, Scott. Go.
You did touch on that you sometimes use your astrophotography in your classroom. Do you use it to demonstrate scale, you know, distance?
No, it's kind of like, I mean, every once in a while.
Yeah.
I do. I mean, so I used M33 at one point to demonstrate, you know, dark matter, but most of the time it's it's just because they measure the, you know, the velocity curves of M33 at one point. But it's basically just for fun. I give them breaks during class because the classes are 2 hours long. And sometimes I'll do you want to see some pictures that I took? And they're like, all right, you know, they look.
I see.
And
right.
but they really like it. So
pretty much blow them away. So that's great.
Well, no one really knows how it works. They think I have a gigantic scope. They think I'm going out in the middle of Everglades somewhere, you know, where there's no light pollution.
Yes. It's $1 million.
No, it couldn't be. You remind me of a good friend of mine that has sometimes been on Star Party. Jason Gwenzel has a fairly small setup and does similar amazing work. And your work, what I loved about your presentation there is the process you came up with works. You were able to save money. You got a setup and you stick to your process and you get very, very accurate results, and you understand why you're doing each of your steps. It's not like you're following some sort of a script, you know, and you're getting all of that detail because of that, and it looks really good. You say you've been doing it for a couple of years, but I think with the mind you've got, it probably didn't take you long to grasp why you did either all the steps, what you were doing to the image and what that was, you know, and how some experimentation, I'm sure.
Yeah, I mean, it's not particularly easy. I mean, I did photography before I started astrophotography, but it's a completely different thing, terrestrial photography.
Right. To do darkroom work. Is that correct?
What was that?
You did darkroom work with film and.
Yeah, I mean, back in the day, I did a little bit of darkroom stuff.
Sure.
But yeah, it's fun, you know. So, yeah, I mean, we might try to do something because I teach at the school. We might try to do some sort of thing with the students, like
sure,
to get something going. At some point.
Well, anytime I think students can get hands-on with anything, you know, it adds a whole new dimension to the learning process.
Yeah. So
yeah, the nice thing about your process is I saw you hit the heavy hitters, Horsehead, and you know, a lot of the brighter targets. But if you dare go after some more obscure targets, your process will get you there without any, you'll when you see your data, you'll see something there and go, oh, is that what that is? You're primed to do all sorts of different types of data that, it may be off of the beaten path. And that's when the things go, things get even cooler, because it's like, yeah, I've imaged a rosette and it's beautiful, but now that there's something obscure and faint over on the shoulder of Orion. Let me image that and see what that looks like and see what I can do with it. That's what you'll end up going.
The my light pollution though is pretty rough.
8, 9, yeah.
Yeah. I mean, if I had a mono
That's a lot of light pollution.
It's a lot of light.
Back in the film days, that would have been impossible to shoot in. For
Yeah,
sure.
I think you're gonna get there, and like I said, you already understand your process very well. I had someone tell me at the Astronomical League conference when I told them I started my Milky Way stuff, and I'm getting up to 5 minutes of it's wide field, but I'm getting sharp stars in a 5 minute exposure of the region, and seeing a lot more stuff there than you get. So and they confirmed, yeah, you're getting more signal to noise by being able to image for that long at these lesser areas. You'll start seeing some more tendrils and Bach globules. Heck, I kind of look forward to it.
That's cool.
Getting there, but yeah, no, loved what I saw there, and I'm by no means an expert either. I can't remember what SAR stands for.
Right.
But we both love, we love the night sky and we love this hobby, and you made a way. I go to dark sites and fight polar alignment all the time because that was my solution. 2 hours and a dark sky with binoculars, and then I set up. Your solution works just as well, and you create beautiful images. So there's never just one way to skin a cat with this hobby.
Thanks.
So, yeah, love it.
Nice. Thanks.
Well, Rob, thank you. Thank you
No
very
problem.
much
Thanks.
for coming on.
Yeah.
I know it's late
Thank
tonight,
you.
so especially in Florida. So
yeah,
and we hope to have you back on and see some more of your work. So
yeah, sure. No problem.
thank you. Thank you.
Yeah, thanks.
Okay. All right. We have one last presentation, and this presentation is being given by a gentleman who is an astrophysicist and a science communicator in Nigeria. And he does his work by uniting students with citizen science across several countries within Africa. His program is called the Pan-African Citizen Science E-Lab, and his name is Miracle Marcel, and he pre-recorded a presentation for us simply because the internet was just a bit too slow to do a live presentation. So Miracle, if you're watching this, thank you for participating, and we hope to hear more from you as your program progresses. So here we go.
Hello, my name is Miracle Chibuzo Marcel. I am the founder and the director of the largest citizen science community in Africa called the Pan-African Citizen Science E-Lab. So in this program, I'm going to be talking about our project and our achievement over the past 3 years. So in table of content, I will be introducing Lab, our key project, and our results. So Lab was founded in December 4th, 2020, and our aim is to promote hands-on activities in astronomy and space science through citizen science and soft astronomy research in Africa as a means of advancing space exploration and enhancing space education and outreach. So, and how we do that is by collaborating with entities in the global north and bringing those opportunities to Africa. And all our activities are online. All our activities are based online. So here is your official logo showing the map of Africa. Here you can see individuals with their computers or phones are analyzing and reducing space data. And that is exactly what we do. We also have a WhatsApp group where we interact within our community. So for the general requirement, all Pascal projects are suitable for all individuals, regardless of age, religion, country, sexual orientation, academic or professional affiliations, levels, etc. So to participate in our project, what you just need is to have a basic knowledge of computers, most especially Windows operating system, internet, and passion for space. Now in our organization, we have different kinds of projects classified as primary project and secondary projects. The primary projects are our main projects, and I'm going to be describing them one after the other. So the first of our primary project is the Pan-African Asteroid Search Campaign, and we collaborate with the International Astronomical Search Collaboration. We are their biggest partner in Africa. And in this project, we contribute in planetary defense through discovering new asteroids. We submit the report to the Minor Planet Center so that the orbit of these asteroids can be classified and continuous monitoring can be done in order to avoid events like this. We use the astrometrical software to analyze the images. Here you can see there are about 4 images taken at different time intervals. Here is the blinking windows that blinks the images in order for you to see if an object is moving or not. That is how we detect asteroids. The data we use are gotten from the Penn stars located at the University of Hawaii and the Catalina Sky Survey located at the University of Arizona. Now, in this chart, there are more surveys around the world observing the sky, scanning the sky, and taking data, asteroid data. But these two are the most. They collect the most asteroid data. And now they have automated system in them that detect this asteroid, but not all of these, not all of these asteroids are detected. So they send the data, those data to the International Astronomical Research Collaboration so that we can use the manpower to discover these asteroids. So we are part of them, the Pan-African Asteroid Search Campaign. And here we engage different entities across Africa in the asteroid search campaign. So here is just one of our groups, the Amateur Astronomy Libya. So this is where the teams will download the data, analyze the data, submit it through here. So this is just the demonstration. So for the tools, to participate in the asteroid search, our participants would need Windows operating system, internet, and Astrometrical. Astrometrical is a free software. Now, in training, we have recorded videos in English, French, and Arabic. And here is just one example of one of my recordings in English. We also have Arabic and French. We have some of our members volunteer and develop those videos in other languages too. We also conduct online training via Zoom. So far, we have discovered 32 asteroids, and those asteroids were discovered by about 60 of our citizen scientists. However, we still have hundreds of preliminary discoveries that are yet to be confirmed. So here is the academic calendar for the new academic year. We started this August. It runs every month till May. That is how we conduct it every year. So here is our second project, Exoplanet Amphimetry, and we collaborate with NASA Exoplanet Watch. So in this research, we contribute data. We contribute data in order to refine the mid-transit period of already discovered exoplanets in order for the future missions like the James Webb Space Telescope to study them again and in details in order to detect if there is life or no life in them. But the reason why we are doing this is because when these exoplanets were discovered by the Kepler and the TESS missions, their periods were not accurate. So we are actually redefining their mid-transit time in order to improve their period. So we reduce the data with exotic software to produce this light curves. And after that, we submit the report to the American Association of Variable Star Observers. To participate in this project, we have 3 sources of data. Through the Exoplanet Watch website, you can request data directly from NASA. They would give you data if you submit your email there. We also have access to the Micro Observatory. There you can schedule your own missions. You can observe stars, okay, using the Micro Observatory. So this is the process of scheduling. And after requesting it, the Micro Observatory is going to turn around to focus on that spot. We also use the Lost Commons Observatory for observation. We are part of the Global Sky Partners of the Lost Commons Observatory. We have about 100 hours of observation time for our research and other endeavors also. So the tools for this research, any operating system, internet, Gmail. Gmail, not email, because this exotic program is a Python program and it is mounted on Google Colab. So to be able to have access to it, you need a Gmail. And all the software is online. For the training methodology, we have recorded videos. I also offer online training via Zoom. And here's an example of the recorded video. So in this project, our aim is to make our citizen scientists to contribute to peer-reviewed publication in order to enhance their academic and professional status. But being citizen scientists, they do not have advanced level of astronomy in order to carry out professional astronomy research. So we sought for some research they can do without advanced knowledge of astronomy, and one of them is on double star research. We collaborate with Dr. Richard Freed, the president of the Institute for Student Astronomical Research in the United States. And in this research, what we do is to update the position angle and the separation of these double stars. We also verify if they are binary stars or optical double stars. So the students write papers, they write manuscripts on their findings and submit to the Journal of Double Star Observation. So far, we have written since this year, 2024, we started this year, we have written up to 12 manuscripts, but 4 have been published. So in the training methodology, we have recorded video like this and online interaction with the research instructor. For the tools, you can use any operating system. You would need internet, you need AstroImagery and other programs. Then we have radio contact to ISS with amateur radio on the International Space Station. This opportunity is going to allow our African citizen scientists to interact with astronauts aboard the International Space Station in order to ask them questions. This is a project that is usually seen in advanced countries. However, entities in South Africa and Morocco also conduct this exercise, but we are the first organization that is going to bring it in the African society, and we hope to make it permanent. So here is an AI generated image of how the event is going to be. The students are going to interact with astronauts via Zoom, and we are getting prepared to conduct this starting from 2025. So in the astrophoto visual development, we teach our citizen scientists how to process space images to produce colorful visuals. So we teach them how to process images from the Hubble Space Telescope, the James Webb Space Telescope, and the Los Cosmos Observatory. So for the training methodology, we have recorded videos, we have online training via Zoom. We have Photoshop training, we have GIMP. So in our telescope giveaway program, we collaborate with GNP Grodet and AFERS in distributing telescope across Africa. And the purpose of doing this is because we are working with a whole lot of teachers across Africa. And some of them, they need this telescope for their teachers training program. So we collaborate with this organization to distribute telescopes to them. Another purpose of this telescope giveaway is that there are some countries in Africa we find it so difficult to recruit citizen scientists. So it means that the astronomy knowledge in those places are very low. So when we find somebody from that place, we give that person telescope for astronomy outreach in order to spread astronomy and also to recruit citizen scientists. Live observation via SLU Webb telescope. So we use the SLU telescope for live observation. Here is the dome. We use it to observe the moon, the sun, live, okay? Live observation, not through email. Live observation. We can also use it to observe deep space images. And most importantly, we use it to observe eclipses. Like these are the pictures from the eclipse that happened in North America in April of this year. We're observing it right from Africa while it is happening in America.
Excellent.
So here is the map of the world showing the different places in the world where the SLU telescope is located. So they have location in Chile, they have location in Canary Islands, and they also have location in Australia. They also have mobile telescope. They move around the world for eclipse observations. So in order to evaluate our results, we issued surveys to our group leaders in order to know how they are adopting our project in their classroom. So from the survey, we got that 691 citizen scientists have been engaged across 45 countries in Africa. Mind you, there are about 54 countries in Africa, so 45 out of 54 countries have been engaged. Now, we have about 70 groups. We work in groups, we don't work individually, we work with groups. Now, out of those 70 groups, we classify them according to levels. For instance, A is equal to 15. A represents national space agencies, national astronomical societies, national observatories, and other national entities. B is equal to 25, representing university groups. And C is equal to 30, representing private astronomy organizations and also including secondary schools. So here is the gender identities. Most of the people that fill the surveys identified as male and female. Levels of education, we have secondary schools, we have bachelors, we have masters, we have PhDs. So from here you can see that bachelors have the most participation. And for these PhDs, the PhDs are mostly university researchers and lecturers adopting our project in their classroom and engaging these students. So our particular project, the 4 active ones, from the survey, we discovered that the asteroid search is the most pronounced, although others we recently incorporated them. However, the asteroid search has been with us since the past 3 years. So here is the year of participation of citizen scientists. We started this program in 2020, and the number, we keep recruiting people. The number have been increasing every year by year, and we are in 2024. So there are 5 geographical zones in Africa. So here are the population of citizen scientists from each of these geographical zones. So here is a map of Africa showing the countries where we have expanded our network. The countries in blue are the countries who have expanded our network. We are still looking for participants from Mali, from Mauritania, and Cape Verde, and other countries. So our project has been contributing to 6 out of the 17 SDG goals, Sustainable Development Goals, which are quality education, gender equality, decent work, and economic growth, gender inequality, reduce inequality, peace, justice, and strong institution, partnership for the goals. So we have written papers on about our organization, and also we are writing papers on each of our projects. So far we have written 2, and we are still writing more. So if you want to read everything about our organization that I have just explained now, I want you to go to our website and go to the publication page so that anytime we drop any paper there, you can have a look at it. You can also sign up for our newsletter so that you can receive a notification when the papers are ready. They are still undergoing peer review. So we are looking for collaborators across Africa and beyond. We are looking for collaborators. So if you are interested in collaborating with us, please reach out to us. Thank you so much.
Okay, that was great. Let me get rid of that mute. All right, there we go. I think that Miracle is actually on with us right now, and I don't know if his are you able to hear us okay, Miracle? Yeah, not hearing your voice here, but I do want to tell you that you have a fantastic program. I did share your website in the text messages so that people can click on it and check it out. And it's wonderful to see citizen science being conducted in such a way. Being that it's all online, I know that you are working across Africa, but it looks like anyone from anywhere in the world could participate. So I want to thank everybody for tuning in to the 155th Global Star Party and, listening to our presenters. We had some amazing speakers on tonight, and we hope that you tune in next time for the 156th Global Star Party. And until that time, you guys keep looking up, and thank you once again.
JUICE is coming back to Earth, but not for long. The spacecraft is doing a double world first, the first ever lunar Earth flyby, and the first ever double gravity assist maneuver. Let's learn more about these flybys, why they're important, and why it's taking us so long to get to Jupiter. Last year, our Jupiter Icy Moons Explorer, also known as JUICE, set off on its 8-year journey to Jupiter. JUICE is on its way to study Jupiter and its 3 largest moons, Callisto, Europa, and Ganymede. The mission will investigate these moons' potential to support life by examining their subsurface oceans. JUICE is expected to arrive at Jupiter in July 2031, 8 years after launch, after a series of flybys of Earth, Venus, and the Earth-Moon system, the first maneuver of its kind. But why is the journey so long? At their closest point, Earth and Jupiter are separated by almost 600 million kilometres. At the time of this video, JUICE has already travelled over 1,000 million kilometres, yet it's only 15% of the way there. The answer depends on a variety of factors that our flight dynamic experts know well, from the amount of fuel used to the power of the rocket, mass of a spacecraft, and geometry of the planets. What are the challenges to get to Jupiter? 1. The Earth is moving. On the surface of Earth, typically the fastest way to travel somewhere is the straightest possible line. However, in space, straight lines are a massive waste of energy. When we look up at the night sky and track the motions of planets, moons, stars, and galaxies, you'll see they're always in motion around another object. When we launch a rocket, it doesn't leap from a still Earth, but from a planet zooming at about 30 kilometers per second around the Sun. As such, a spacecraft launched from Earth already has a great deal of orbital energy, the only unit that matters when determining the size of an orbit around a central body. Just after launch, a spacecraft is in more or less the same orbit as our planet is around the Sun. To break free from this orbit and fly in the shortest possible straight line from Earth to Jupiter would need a big rocket and a lot of fuel. It can be done, but the problem is you'd then need even more fuel to break and go into orbit around Jupiter and not be flung past it. 2. Jupiter and Earth are both moving and not on the same route. Jupiter and Earth are always moving with respect to each other. This means at their furthest distance, when they are on opposite sides of the Sun, they are separated by a whopping 968 million kilometers. The shortest distance between them is just under 600 million kilometers, when they are both on the same side of the Sun. But they're only in this position for a moment before the distance grows again, and the distance never remains constant. All the solar system planets are moving at different rates in their orbits around the Sun. Launching a spacecraft is like throwing a ball at a moving target from a moving vehicle, not an easy feat. Engineers must calculate the ideal time to make the jump on a circular path from Earth's orbit to where Jupiter will be when the spacecraft arrives, not where it is when the spacecraft leaves Earth. So assuming we have the most powerful launcher available and we launch on the shortest trajectory at the right time when the planets are aligned correctly, how long would it take? Early space missions such as the Voyager and Pioneer probes made the journey in less than 2 years, and the fastest any object has travelled to Jupiter was the New Horizons mission. Launched on 19th January 2006, New Horizons made its closest approach to Jupiter on 28 February 2007, taking a little over a year to reach the planet. However, all these missions continued onwards, receiving a boost from Jupiter, but none were captured by the orbit like JUICE will be. 3. We want to be captured by Jupiter's gravity, not boosted by it. To get into orbit around the huge planet, we need to lose some energy, but slamming on JUICE's brakes at Jupiter would require an enormous amount of fuel. Engineers need to control the spacecraft's mass, balancing the amount of fuel with the instruments it needs to carry to complete its mission. The more mass the spacecraft has, the more fuel it needs to carry, which increases its weight and makes it more difficult to launch from Earth. JUICE is one of the heaviest interplanetary probes ever launched, at just over 6,000 kilos, with the largest suite of scientific instruments ever flown to Jupiter. To get a spacecraft into orbit around another planet, we must match its orbital energy. When JUICE was launched, its orbital energy was the same as Earth's. It must gain energy to overcome the pull of the Sun's gravity and will do so by stealing some orbital energy from Earth and Venus. Depending on the relative direction of motion of the planet and the spacecraft, a gravity assist can either speed up, slow down, or change the direction of the mission. The spacecraft also deflects the planet, but by such a minuscule amount as to be insignificant. Nonetheless, Newton's third law of motion has been preserved. To every action, there is an equal and opposite reaction. The world of orbital mechanics can be a counterintuitive place, but with a bit of patience and a lot of planning, it allows us to do a great deal of science with just a little fuel. So, JUICE is taking the scenic route, using the gravity of other planets to carefully adjust its trajectory through space and ensure it arrives at Jupiter with precisely the right speed and direction. This incredibly complex, constantly evolving route has been carefully planned out by JUICE's dedicated mission analysis team over the last 20 years. Somewhat counterintuitively, using the lunar Earth flyby to slow JUICE down at this point in its journey is actually more efficient than using the flyby to speed it up. If we had instead used this flyby to give JUICE a boost towards Mars, we would have had to wait a long time for the next planetary flyby. This first braking maneuver is a way of taking a shortcut through the inner solar system. JUICE will come extremely close to both the Moon and Earth, meaning that real-time pinpoint accuracy is required in all navigation maneuvers. During the flyby, operators will keep a careful watch on the data coming down JUICE, making any tiny adjustments needed to keep the spacecraft on the right course. Lunar Earth Flyby provides a prime test environment for instrument teams to collect and analyze data from an actual surface in space for the first time. For some instruments, this is the only opportunity to make certain measurements during JUICE's entire 8-year journey to Jupiter. It will give scientists and engineers the chance to calibrate their instruments, smooth out any remaining issues, and who knows, they may even make some surprising scientific discoveries. This event will be a world first. It will change JUICE's speed and direction to alter its course through space, but it's a daring feat. The slightest mistake could take JUICE off course. Thanks to this flyby, Earth will bend JUICE's trajectory through space, braking it and redirecting it on course for a flyby of Venus in August 2025. From that moment on, the energy boost will begin, with JUICE being whizzed up by Venus and then twice by Earth, the space exploration equivalent of drinking 3 back-to-back espressos. Once JUICE arrives at Jupiter, it will get close to Jupiter's moons, trading energy with them that they've held onto for billions of years, to get a view of these environments like never before, helping us answer some questions such as, could there be life under the frozen oceans of Ganymede, Callisto, or Europa? What can we learn about the formation of planets and moons throughout the universe? Through the wonder of flight dynamics, by trading energy with the universe, we will soonish find out.